In this complete game development course, you will learn how to develop a variety of games using JavaScript. Frank's courses are top-notch, and he has a really creative way of presenting things. You are going to love this course.
Hi coders, in this class we will use HTML, CSS and JavaScript to build 9 separate game development projects. I will write and explain all the code from scratch, line by line, using just plain vanilla JavaScript, no frameworks and no libraries. We will start by learning individual 2D game development techniques on smaller standalone projects, and once we covered everything, we apply all of them to build a simple mobile game, simple point-and-shoot game, and a more advanced, fast-paced 2D side-scroller with precise keyboard controls and special visual effects. My name is Frank and I'm a front-end web developer. If you want to learn even more about game development and creative coding, you can check out my YouTube channel. In this course, we will learn everything you need to know about sprite animation. We will write the JavaScript code that handles seamless, endlessly scrolling parallax backgrounds. We will learn how to extend JavaScript classes to create a variety of enemy types with different visuals and different behaviors. I will show you how to implement state design pattern to manage player states and special abilities. We will learn how to use collision detection by color, collision between circles and between rectangles. We will add different particle effects and many other things. This class is made out of 9 separate standalone projects and a couple of special lessons, so if you already know some of these techniques, you can skip around. This class is not for complete beginners, but if you are already comfortable with the basics of JavaScript and you understand functions, for loops, objects and arrays, come join me and let's build some games. In the first class, we will explore 2 different JavaScript techniques you can use to animate sprite sheets, and we will build this project where you can choose different player animations from the drop-down. We are giving away a lot of free art assets. You can download them in the video description, and you can use them to follow along with this course. For more beautiful game art assets, visit this website. Now let's do a quick JavaScript setup. I will show you how little code you need to animate something on canvas. I create a custom variable called canvas that will hold a reference to my actual HTML canvas element I created in index.html. I point JavaScript towards it using getElementById, and I pass it ID I gave it, canvas1. Constant variable I call, for example, ctx, shortcut for context, is equal to this canvas variable from line 1. Dot getContext, and I pass it 2D. I could also pass it WebGL here, which would give us access to a completely different set of drawing methods, but that's for another video. Now I have all Canvas 2D drawing methods stored in my custom ctx variable, and I can call them from here. For example, ctxFillRect will call a method to draw a rectangle on canvas. If I console log ctx, we can inspect this object. It has some properties which basically are global canvas settings, such as fill style that says color of shapes we draw, or font, which sets size and font family of text we draw on canvas. This tutorial will be focused on sprite animation. We want to learn how to create animated characters for games, so we are most interested in built-in canvas draw image method, which sits right here. I will explain everything you need to know about draw image method and its 3 versions in a minute. It's easy, don't worry about it. Before we do that, I will quickly finish canvas setup. To make sure we have correct scaling, I need to set canvas width and canvas height. By default, canvas will be set to 300 times 150 pixels, and our drawings can come out distorted. That's why I will manually set it to 600 times 600, the same values I gave it in style CSS. I create a custom variable called canvas width. I will use capital letters here to make it clear. This is a global variable. I set it equal to canvas from line 1 dot width, and I set it all to 600. Same width I gave it in style CSS. I do the same for canvas height, also 600. Now that we made sure scaling is correct, let's bring an image into the project. In this tutorial, I want to show you 2 different ways you can animate sprites. Very simple one for beginners, and then more advanced, more complex and flexible way, where you can just run commands like run, jump, sit, and it will play the correct animation for us. When you know both, you can decide which one to use when you are building your games. I want everyone to get the same result. That's why I will be giving away this animated sprite sheet for free today. To bring image into JavaScript project, I can just declare a custom variable I call, for example, player image, and I set it equal to new image like this. This is a built-in image class constructor. It will create HTML image element, same as you would create if you put image tag, img tag in index.html markup. We can append it to our web page if we want, but today we will just use it to store that sprite sheet image for us so that we can animate it with JavaScript. I need to give it source, so player image variable from line 6 .src, and I set it to path to my sprite sheet. Your path might be different, it depends on how you organized your project files. Let's animate something on canvas. I create a custom function called, for example, draw frame. Actually, let's call it animate because this is our animation loop. Let's make sure that's clear. Inside animation loop, first I want to clear old paint from canvas between every animation frame. So I take ctx variable from line 2 dot clear rectangle built-in method. It expects 4 arguments to specify what area on canvas we want to clear. I want to clear the entire canvas, so from coordinates 0, 0 to canvas width, canvas height. Now we can draw. I will just test if everything works by drawing a simple rectangle at position 50, 50, and I give it width and height of 100 pixels. Now I can call a request animation frame built-in method, which will simply run a function we pass to it. It will call that function once. If I pass it animate, the name of its parent function from line 9, it will just run over and over, create an animation loop. So we declared animate. I also have to call it like this, and we have a black rectangle drawn on canvas. If we don't specify fill style, color of shapes on canvas always default to black. It looks like a static image, but it's actually animating the same rectangle over and over. I can simply prove it by creating a global variable called x. I set it to 0, and here on line 12 I replace hard-coded value with this variable, and every time animation loop runs I increase x by 1. I told you you don't need much code to animate something on canvas. Well done, you are a programmer now. See you later. Okay, there's a bit more I can show you. Let's put it back and let's use built-in drawImage method to draw our sprite sheet on canvas. DrawImage method is a bit special. You can pass it 3 or 5 or 9 arguments depending on how much control do you want to have over the image you are drawing. The first argument is always the image you want to draw, so I pass it player image variable from line 6. Then I pass it x and y coordinates, where on canvas I want my image to be drawn. If I pass it 0 for x and 0 for y, it will be drawn from the top left corner of canvas, coordinates 0, 0. It will also keep the image at the original width and height. The sprite sheet I'm using has 10 rows and 11 columns of animation frames. It's many times larger than my canvas, so now we can only see this small part, 600 times 600 pixels, in the top left corner of my sprite sheet. It's 600 times 600 because that's the size I set my canvas to. So this is the version of drawImage with only 3 arguments. It works and you can change x and y coordinates to move your image around. But you would need to resize your images using some other programs such as Microsoft Paint or Photoshop. But you don't have to do that because drawImage also accepts 5 arguments. That's its second version. If you pass it 5 arguments, the 4th argument will be width and 5th argument will be height, so we are now able to scale the image up and down, and we can also stretch it vertically or horizontally. If I pass it canvas width and canvas height, it will stretch the image to match my canvas area, 600 times 600 pixels. And since the image is not the same ratio as my canvas, you can see the image is stretched just a little bit. Let's remove the black rectangle by commenting out line 11. I can pass any values as width and height, and JavaScript will just stretch my image based on these values. You can also change x and y to move the entire image around. The final third version of drawImage method accepts 9 arguments. This gives us the most control over the image. The first argument again is the image you want to draw. The next 4 arguments determine rectangular area we want to cut out from the source image. Source x, source y, source width, and source height. And the last 4 arguments will tell JavaScript where on our destination canvas we want to draw just that cropped out part onto. Destination x, destination y, destination width, and destination height. These last 4 values basically work the same as these 4 values in the previous drawImage call I showed you. The only difference is they are not used to position and stretch the entire image, but just the area we cut out using these arguments. I comment out line 12, but I will leave it here for a reference. And on line 13, I will add source x, source y, source width and source height arguments, and I will use them to cut out only one dog at a time, one frame from my large sprite sheet. So these 4 values determine area we cut out from the original sprite sheet. And these 4 values determine where on canvas we want to place that cutout piece of image onto. If I set source x to 0, source y to 0, source width to 200, source height to 200, we are cutting out square 200 times 200 pixels from the top left corner. There is nothing in the area. If I change it to square 400 times 400 pixels, we can see part of our dog. I can put any values here and cut out any chunk of the original sprite sheet I want. I can also scale it, stretch it, I can do whatever I want here. I create a global variable called sprite width. Let's have a look at our sprite sheet. If I take width of the entire file and divide it by number of columns, I get width of one frame. My sprite sheet is 6876 pixels wide and it has 12 columns. 6876 divided by 12 is 573. I will use 575 for now because I made the last frame a bit smaller when assembling my sprite sheet in Photoshop. And there's some margin that snuck in. Sometimes when you see that your animation is moving sideways when it shouldn't, try to fix it by adjusting width and height by small pixel amounts and watch what happens. I will show you a bit later what I mean. It's simple. You can just ignore it for now. Sprite height, or height of a single frame, will be height of my entire sprite sheet, which is 5230 divided by the number of rows. We have 10 animations, 10 rows, so 5230 divided by 10 is 523. On line 15, I can replace source width and source height with sprite width and sprite height variables I just calculated. And now we are cropping out exactly one frame from our sprite sheet. And in destination width and destination height, instead of stretching it to cover the entire canvas, I can also use sprite width and sprite height variables here. And we are drawing the frame at its original size. If you are still not clear what each of these individual arguments passed to draw image method does, feel free to play with it, change the values and see what happens. It's quite straightforward once you get used to it. Here I am giving it an image I want to draw. These 4 values specify a rectangular area to crop out from the original large sprite sheet. And here I am telling it where I want that cropped out piece of my sprite sheet to be displayed on canvas. If I set source x coordinate to 1 times sprite width, I am jumping one frame. As this number increases, I am moving to the right, jumping by the amount of sprite width. This way I can display my animation row frame by frame. When this number gets too high, there will be no frame there eventually. So source x argument allows us to cycle through sprite sheet horizontally. If I want to swap between different animations, the way our sprite sheet is structured, I have to travel through it vertically. We have source y argument for that. Again, starting from top would be 0 times sprite height variable from line 9, and that will give me the top row. In this case, we have idle animation there. 1 times sprite height is row 2, jump animation, then there is fall animation, running, and so on. Traveling through this sprite sheet vertically along the y-axis switches between different animations, and we do it by changing source y argument. Traveling horizontally cycles between individual frames of these animations and can be done by changing value we pass as source x argument. Instead of manually changing numbers like this, let's output it to variables. I create variables called frameX and framey, and I set them to 0 initially. Then I just replace hard-coded zeros inside my drawImage method with frameX and framey, and now I can swap between animation frames by assigning different values to these variables. FrameX cycles through frames of each animation horizontally. FrameY swaps between different animations. It travels through my sprite sheet vertically. Now let's cover a very simple way you can animate your sprites, and then I will show you proper advanced scalable technique that is suitable for both small and larger game projects. The simple way is this. We know that frameX variable cycles through our sprite sheet horizontally. First row in our sprite sheet is idle animation. It has 7 frames. Inside animation loop on line 18 I can say if frameX from line 10 is less than 7, increase frameX by 1. FrameX++. Else, meaning when it's equal or larger than 7, reset it back to 0. You can notice 2 things. Our animation is blinking and it's going very fast. Let's deal with it. First frame is 0, so last frame is actually position 6. If I change this to 6, the empty frame is removed and blinking is gone. On line 11 I can just change values of frame Y and we are animating different rows in the sprite sheet. Problem comes when I get to frame Y4, which is row 5. We are starting from 0. This animation has 11 frames, but I'm cycling only until frame 6, so we are not playing the entire animation. When I get to this row, we have a problem again. Sit-in animation has 5 frames and we are cycling through more frames here. So now it's blinking, because we are including some empty frames. To get this to work properly, every time we want to swap between animations, we have to change frame Y value on line 11, but also this hard-coded number 6 on line 18. Ideally, it would have to be a variable that always changes to the correct value that reflects the number of frames for each animation row, depending which one we are animating right now. I would solve it by having a variable called, for example, max frame. I would slot it here, and every time I change frame Y variable, I would change value of that max frame variable from 6 to whatever value we need here to display all frames. So 10 for this row and 4 for this row, since we are animating from frame 0. Animation is going very fast. To slow it down, we can use this simple trick. I will create a let variable called GameFrame and I set it to 0. On line 22, inside animation loop, I take this GameFrame variable and for every loop we increase it by 1. So now GameFrame is endlessly increasing as our animation loop runs over and over. On line 19, I create an if statement. Let me just write it and I will explain it when we see the whole thing. I say if GameFrame modulus percentage symbol something, question marks for now, is equal to 0, only then increase frame X. On line 13, I create a custom constant variable called stagger frames. Whatever value I give it, it will slow down animation by that amount. Let's try 5. On line 20, I say if GameFrame modulus stagger frame is 0, only then increase frame X. Modulus operator percentage symbol is also called remainder operator. It returns remainder when we divide the first number by the second. Let's say GameFrame is 17 and stagger frames is 5. 17 modulus 5 is 2. Because 17 divided by 5 is 3, that gives us 15, and remainder to 17 is 2. Remainder operator simply divides the first operand by the second one and returns the remainder. Here I am checking if the remainder is 0. GameFrame is ever increasing in number and stagger frames is always 5. This statement will return remainder 0 and be true every 5 frames. So because I set stagger frames to 5, this code block on line 20 will run every 5 frames, slowing down our animation 5 times. New frame in our sprite sheet will only be served every time the main animation loop runs 5 times. I can also slow it just by 2. 0 here will stop animating. The higher the number you use here as stagger frames, the slower the animation will be. Let's leave it at 5 for now. I think it looks good for most animations. As I said, when I change frame Y to 4, if I want to display all frames in my animation, I also have to change 6 here on line 21 to number 9. For shorter animation rows, like this sit-in animation, it has only 5 frames, so I have to change this number to 4. So now we have a way to swap between animations, but we always have to change 2 values. Let's refactor this code and let me show you more advanced sprite animation method that allows us swapping between different animation states by changing just one value. We are venturing into a bit more advanced territory. If you are new to JavaScript, don't worry if it takes you a bit longer to understand what I'm about to show you. It becomes easier with practice. We all started somewhere. I delete code between lines 20 and 23. We used it to cycle between animation frames horizontally. In this more advanced method, we will do it differently. I set frame Y to 0, that's my top row, idle animation. I also delete lines 17 and 18, they are commented out anyway. Let's clean this up. Inside animation loop on line 17, I create a let variable called, for example, position. Its job will be to cycle through horizontal sprite sheets, but in a different way. We will need this later. I take a GameFrame variable from line 12. This variable is increasing over and over on line 20 as animation loop runs. I divide it by stagger frames variable from line 13, and I wrap all of this in math.floor to get rid of potential decimal points. I want this value to be only integers, whole numbers without decimal points. Then I take this entire value and I do remainder operator and 6. 6 is here because I'm doing idle animation, which has 6 frames, counting from 0. This line of code is not the easiest thing to wrap your head around. I said this would be slightly more advanced. Don't worry if you're struggling to read this, this is not beginner level JavaScript anymore. What's happening here on line 17, GameFrame divided by stagger frames means we will have to increase GameFrame 5 times before we get to 1. Because as GameFrame variable increases, 1 divided by 5 is 0.2, 2 divided by 5 is 0.4, 3 divided by 5 is 0.6, GameFrame 4 divided by stagger frames 5 is 0.8, and only when we get to GameFrame 5 divided by stagger frame 5 we get value of 1 here. So as GameFrame cycled from 1, 2, 3, 4, 5, by dividing GameFrame by stagger frames, we got 0, 0.2, 0.4, 0.6 and 0.8. All of these values were turned into zeros because it's wrapped in math.floor. It took 5 animation loops, 5 increases of GameFrame variable to get the number 1 here. When this is 1 modulus 6 is 1 because 1 divided by 6 is 0, and remainder from 0 to 1 is 1. Basically this value increases by 1 every time GameFrame variable increases by 5, slowing or staggering our animation 5 times, making it 5 times slower. We are using math.floor, removing decimal points from these divisions. For the first 5 frames we get 0 modulus 6, which is 0. Then this calculation increases to 1. For the next 5 frames, 1 modulus 6 is 1. Then 2 modulus 6 is 2, 3 modulus 6 is 3, and so on. Position variable increases until it reaches 6. 6 modulus 6 is 0, 7 modulus 6 is 1, 8 modulus 6 is remainder 2, and so on. This calculation makes sure position variable only cycles between 0 and this number. I appreciate that this calculation is quite complex. This is not course in advanced mathematics and logic. So for now, just take this little formula here and believe me when I say it works. Don't worry about understanding it completely. We are focusing on JavaScript today. Being able to understand this calculation has nothing to do with your ability to be good with JavaScript. These are two unrelated skills. On line 18, I take frameX variable from line 10 and I set it equal to sprite width from line 8. And I multiply it by this position variable we just calculated on line 17. As I said, this position variable will cycle between 0 and number we put here. First row in my sprite sheet has 7 frames, starting from 0. Frame X will be cycling through these values horizontally. On line 19, inside the draw image, I remove sprite width because width of our sprites is already accounted for inside my frameX variable on line 18. I misspelled stagger frames on line 17. When I fix this small typo, we can see this is working and we are animating row 1 in our sprite sheet. Don't feel that you need to fully understand this calculation on line 17 to be good at JavaScript. I did not come up with this formula. Tricks like this are usually figured out by someone much smarter than me. We can just use them and they will work for us. I could have achieved the same result using a bit more code and simple, more readable calculations. This is more complex and hard to read for beginners because it's such a short calculation. It's kind of a neat trick to use this, but it's not a necessity. I like it because it makes the code look clean and compact. I can still change value of stagger frames variable on line 15 and it will slow down or speed up my animation. This is really nice code base to animate any sprite sheet, but it can be done even better. To swap between animations, I still have to change frame Y variable on line 11 and I have to make sure that this value on line 17 sets the correct amount of frames per row to make sure we don't have any empty frames or that we are animating all available frames from that particular row, depending on what animation we are currently drawing. I would like to have a code structure like this. Some kind of data array called, for example, sprite animations, that contains objects. Each object's name in this array is the same as the name of that particular animation it holds data for. So, for example, idle, jump, run, and so on. Each of these objects can contain additional data. For example, for irregular sprites, it can be pixel values for width and height. That can be different for each frame. And mainly it will contain locations array. This location array will hold a set of JavaScript objects and each of these objects will have X and Y property. Each of these objects represents one frame in that particular animation and its X and Y properties will be coordinates we need if we want to use draw method to cut out this particular frame from the sprite sheet. That way we can access any frame we want anytime by directly targeting positions in this array. I can just cycle through this location array with a for loop and it will always play the entire animation for me without the need to set up number of frames each animation has each time. It will know how many frames that animation has based on the number of objects in this location array. Each object will be one frame. So how do we create a data structure like this with JavaScript and how do we map it correctly to match our sprite sheet? Let me show you. On line 14, I create a custom constant variable I call, for example, sprite animations, and I set it equal to an empty array. This will serve as the main container to hold all data for all my animations. I will create another variable I call animation states. This will also be an array and I will use it as a place where I can create kind of a simple map that will match my doc sprite sheet. I will go through my sprite sheet row by row from top to bottom. For every animation row in my sprite sheet, I will create an object like this, with two properties. Name property will be whatever I want to call that animation row. So for the first row, let's call it idle. And I will also need frames property. I check my sprite sheet and I see that idle animation is made out of 7 frames. The second row I will call jump animation, and it has 7 frames. I will create an object like this for every row in my sprite sheet, going from top to bottom. But before I do that, let's check if it works. On line 15, I have this animation states array, which currently contains 2 objects, one for idle and one for jump animation. I could have also given it more properties, but this sprite sheet is not irregular. So name and frames properties is all I need to map coordinates for each animation frame. I take animation states array and I call built-in array for each method. For each method, executes provided function once for each array element. I will do ES6 syntax here. This is so-called arrow function. It's a simplified syntax to write function expression in JavaScript. I can skip function keyword here and I just create brackets where arguments I pass to this callback function go. With for each, the first argument we pass to it is just a variable that will represent each element in the array as we are cycling through it. I will call it state. As for each method runs, state will first represent this object, then this object, and so on if we add more. I'm simply saying inside this callback function I'm about to write, refer to these objects as state. So this name property can be accessed as state.name, for example. I will also pass it second argument I call index. Index is another built-in feature of for each array method. It simply stores number of each element as we cycle through the array. So this first object will have index 0, this will have index 1, and so on. I expect you understand basic array manipulation with JavaScript and fundamental methods like for each, but I still wanted to explain in case we have some beginners here. So this callback function will run for each element in my animation states array. Now I want to run through animation states and create data structure like this that maps my sprite sheet and coordinates for each frame. I create let variable called frames and I set it equal to an object. Inside I will have property called LOC, location. That will be an empty array for now. I will create a for loop that will cycle through state.frames property. So for idle animation it will run 7 times as I set it here on line 18. Every time this for loop runs, I want to calculate x and y coordinates of that animation frame from my sprite sheet and I want to place them inside location array on line 27. How do I calculate that? I create a temporary variable called position x and it will be equal to j variable from the for loop times sprite width that I set to 575 pixels earlier. As a for loop runs and j increases, position x will be calculated for each frame. I will also need position y, which will be index from line 25 times sprite height. We declared sprite height earlier and we set it equal to 523 pixels to match our sprite sheet. Position y will be the same for all 7 frames of idle animation. When for each method moves to the second animation object here, index will increase and for that animation row, different position y will be calculated. This might be quite a lot going on if you are a beginner. This is more advanced than the first sprite animation method. Don't feel discouraged if you are struggling to follow. It takes time and practice. It wasn't easy for any of us at first. So this for loop calculates position x and position y for each frame as it cycles through my sprite sheet. Every time we calculate x and y, I take frames.location array from line 27 and I use push method. I create another small object here on a fly. It has x property set to position x from line 30 and y property set to position y from line 31. I push these values into my location array on line 27. So this for loop will run through all the frames in one row, in this case 7 times, and once we create 7 objects with x and y coordinates and push them into location array, I take sprite animations array from line 14 and I create a new key in there. I will create something called key value pair. Key is the name of the property, value is the value of that property. So I'm taking sprite animations array from line 14 and I'm passing it state.name, which will first refer to idle, then to jump, as for each method runs through animation states array. I'm saying create a new key, new property in sprite animations array, call it idle, and its value will be frames from line 27. Frames object contains locations array, which I just filled with 7 objects that contain X and Y properties for each frame in this animation. That's it. We created a data structure that maps locations in my sprite sheet. I can console log it now. I can see I made a typo here on line 29. You probably noticed it already. This should be J, not S. So now I'm console logging animation states from line 15, that's fine. But what I actually want to see is sprite animations array from line 14, which we just created and filled with data. You can see that my sprite animations contains 2 properties called idle and jump. If I look inside, each contains location array from line 27, and number of elements in that array corresponds to frames I declared for each animation. Each of these values was calculated here on lines 30 and 31. You can see that all y coordinates for idle are 0, and for jump animation, vertical y coordinate is 523, as we moved onto the second row in our sprite sheet. Now I can replace hard-coded number 6 here on line 40 with length of these locations arrays. I access this location array by targeting sprite animations.lock. Actually no, I skipped one level. I need to specify if I want location array for idle or jump. Let's just hardcode idle here for a moment, and I want length of this array. Remember, I am just replacing hard-coded number 6 that was here. So dot length, and that's it. Now it's dynamic. I can add animations with 4 or 15 frames per row, or however many I want, and it will still work with no blank or left out animation frames. Here I am accessing sprite animations from line 14, idle, location.length. Inside animation loop, we are still calculating frames using frame X and frame Y variables from lines 10 and 11. We don't need these anymore because now we have the exact coordinates stored in locations array. I delete lines 10 and 11. On line 40, I add let keyword in front of frame X, and I will declare frame Y variable here. Frame Y is just the value we can see here, so I can access it by saying sprite animations idle dot location at index position from line 39 dot y. I could do the same thing for frame X, or I can just leave it as is. Both will work. Let's replace idle with a jump. It breaks. Notice that row 1 with idle animation was working and row 2 doesn't, which suggests something is wrong with how we draw vertical position. Inside the draw image on line 43, I remove sprite width value from source y argument. We don't need it anymore as frame y contains complete, already calculated coordinate. Now I can go back inside animation states array and I add data for all the remaining animations. It's important to understand that you can't skip rows here. You have to go row by row from top to bottom to match your sprite sheet because vertical y coordinate is tied to index in for each method. I add full animation with 9 frames, run animation has 9 frames, dizzy 11 frames, sit has only 5 frames, roll 7 frames, and so on. I also need to make sure there is comma between every object. If I try fall, I get blink in. There must be an empty frame. Fall animation is actually only 7 frames. If I put less here, we play only part of animation. If I put more here, we get blink in because some frames are empty. Run animation works. Dizzy works. Sit animation works as well. You can see sit animation has 5 frames and dizzy animation has 11 frames, and I can swap between them easily without having to manually change number of frames like we did before. Roll animation works, bite animation works. Let's go back to idle. Putting hard-coded text here like this is not ideal, of course. I go up to line 10 and I create a variable called player state. I set it to run initially. Down on line 71 and 73, I replace idle with this new player state variable. Now I can swap between animations here on line 10. Sit works, jump works, fall works. In index.html, I create a new div with a class of controls. Inside, there will be a select element with an ID of animations and name animations. Label for animations will say choose animation. I give it some options that match names we gave to animations in script.js file. In style CSS, I target controls and I give it position absolute, z-index 10, top 50 pixels, and transform translate x -50% to center it horizontally. I take controls, select and option, and I increase their font size to 25 pixels. I can also remove the border around my canvas. I want animations to change when I choose different value in this drop-down. In script.js, I take player state from line 10 and I put it up top on line 1. I create a constant variable called dropdown and I point it towards this new select element with ID of animations. I take dropdown and call add event listener on it. I will listen for change event. Every time its value changes, we will take player state from line 1, and since we are inside callback function on event listener, we have access to event object. I'm referring to it as E. Event object has target property. Target is simply referring to an element that was clicked, and it has value property because I have added values myself. Whenever any of these option elements in my dropdown is clicked, player state variable will be set to its value attribute. Now I can easily swap between different animations in my sprite sheet just by selecting different option in a dropdown. Parallax scrolling is when background images move past the camera slower than the foreground, creating an illusion of depth in a 2D space. This is what my game looks without it, and this is what it looks with parallax. Which one do you prefer? Today we are learning about vanilla JavaScript game development for beginners, and by the end of this video you will have deep understanding about endlessly scrolling backgrounds and how to add parallax effect to your games and websites. When we have full control of individual layers, we can match scroll speed to different actions our game character takes. For example, my dog character can sit down and the game stops moving, or it can do this rolling attack and the game speeds up. Art assets for this episode were created by this amazing artist. Check out their website for more if you want. What is the easiest way to create endlessly scrolling backgrounds? How to make different layers move at different speeds to create parallax effect? How to make scroll speed dynamic so we can easily change it? We will learn all of that and more. Let's bring our coding skills one step further today together and have some fun with plain vanilla JavaScript. This tutorial is for beginners. Let's go. Click like please. I create a basic web page markup. In document head, I use link tag to include my style CSS file. We will use it to position canvas. At the bottom of document body, I place my script tag. Script.js file will contain all functionality and logic for our project. I also create HTML canvas element with an ID of canvas1. It will be our main project area and we will draw on it with JavaScript. In style CSS, I take body tag and I set its background to black. Canvas will be set to position absolute. Border 3 pixels solid white. Width of 800 pixels. Height 700 pixels. I do transform translate -50% for x-axis and -50% for y-axis. And then I offset top by 50% and left by 50%. This will center my canvas in the middle of the page, both vertically and horizontally. In script.js, I create a custom variable called canvas and I point it towards my HTML canvas element by ID canvas1. CTX, shortcut for context, will take this canvas variable from line 1 and it will call getContext built-in method on it. GetContext can only be called on a variable that holds a reference to canvas element, and when I pass it argument that says 2D, it will create an instance of built-in canvas 2D API object that contains all properties and drawing methods we will need today. I need to make sure we have the correct scaling, because if you don't set canvas width and height, it will default to 300 times 150 pixels. I create variable I call canvas_width, all capitals, to make it clear it's a global variable. I set it equal to canvas from line 1. .width, which will access width attribute on HTML canvas element we created in index.html. And I set all to 800 pixels. The same value we gave canvas width in style CSS. I do the same thing for height. Canvas_height is equal to canvas.height is equal to 700 pixels. This is how you set up most canvas projects. Now we have our drawing board ready and we can focus on building parallax effect. I want the scroll speed to be dynamic, tied to a variable, so that in our game we can speed up or slow down using special moves with our character. To control scrolling speed, I will declare a global variable called gameSpeed and I will initially set it to, for example, 5. Notice I didn't use const keyword here, I used let. Let keyword in JavaScript is used to declare variables that can be reassigned to different values later. I will need this to be able to dynamically change scrolling speed. It's time to bring images to the project. Art for this episode was created by this artist. I really like his art style. You can download them in the video description. You can use these images for learning purposes. For commercial projects, you would have to purchase a full license from his website. This effect will also work with any other image, but maybe you first want to use the same files I'm using so that you get the same result and don't have to worry about calculating different width and height or making sure your layers match. Once you fully understand the code from today's lesson, it will be easy to switch the images and adjust values so that the codebase works with your own files. The images are very large. If you experience any lagging or frame drops, making images smaller will significantly improve performance. I kept them large on purpose so that we get nice clean visuals, but especially if you are creating a mobile game, these images can be much smaller. You can download the project files in the video description. Our background will have 5 layers. It is perfect to demonstrate seamless parallax scrolling for games. This is one of my favorite 2D game artists. If you want, you can go and check out his website. I will leave a link in the video description. He offers some free art assets you can play with and use in your games, but if you want something a bit more special, his prices are very affordable. There aren't many 2D game artists out there, so if you can, help me out to support them and buy some of their assets for your projects. It will help us to make our games unique, and by purchasing from and supporting our artists, they can make more beautiful game assets for us. To bring image into our canvas project is very simple with JavaScript. I create a constant variable called background layer 1 and I set it equal to new image. This is built-in image class constructor. It simply creates an image element. We can use append child built in JavaScript method and it would slot image tag, img tag, into our HTML file, same as if we wrote that tag in index.html ourselves. we can also choose not to append it, and it will stay hidden, and it will just store the image for us. Image constructor has the same functionality as the document.createElement img. We are simply creating HTML image element and saving it in this variable. At first, that image element is blank, so I access its source property and I set it equal to layer-1.png. For you, the path might be different, depending on how you structured your project files and folders. I left my image files in the same folder with my script file for now. We have 5 layers, 5 different images, so let's do the same thing for all of them to bring them into the project. Let's create animation loop. I create a custom function called, for example, animate. It will contain all the code I need to draw my backgrounds. I will be calling it over and over to create animation. Let's start by calling ctx.drawImage built-in canvas method. This method will take image and it will draw it on canvas. The first argument I pass it is the image I want to draw, so background layer 1 from line 7. I want to draw it at coordinates 0, 0, so from the top left corner of canvas. Then I call built-in request animation frame function and I pass it animate, the name of its parent function from line 18. This way, animate will run over and over, creating my animation loop. On line 19, I need to call drawImage from my ctx variable from line 2. Background layer 1 image is not the best one to use as an example. Let's try layer 2, layer 3, 4, 5. Let's do this at first with layer 4 to see exactly what's going on, and then we can throw in all the other layers. It looks like a static image, but it's actually animating over and over. Let me show you. On line 18, I create a variable called x and I set it to 0. On line 21, inside drawImage method, I replace hard-coded 0 with this x variable, and every time animation loop runs, I decrease x by 1. This will make our image move to the left, in a negative direction on horizontal x-axis. The reason the image is being smudged like this is because we can see all previous frames. We can see old paint. If we want to see only the current animation frame, we need to delete old paint. I use built-in clear rectangle method. It expects 4 arguments to determine what part of canvas I want to delete. I want to clear the entire canvas, so from coordinates 0, 0 to canvas width, canvas height. Now, old paint is being deleted and we can only see the current animation frame. Image is moving to the left by 1 pixel per frame. On line 5, we declare the game speed variable, so down here on line 23 I can say x minus equals game speed, and now scrolling of our game is attached to this game speed variable. If I do 15, it moves much faster. As you can see, the background just moves endlessly to the left and eventually it leaves canvas empty. These images were specifically crafted for endlessly scrolling games and they are seamless. It means you can stack them next to each other and it will look like it's one repeating image. I need to somehow detect when my image has moved off screen and I need to reset it so it can scroll again. Let's try it. What if I say if x is less than minus 1000 pixels, set it back to 0. Else x minus equals game speed. I increase game speed to 15 here on line 5. You can see the image is resetting, but we can clearly see the jump when the reset happens. Let's try 1600 on line 23. Still it jumps. I know that images we are using today are 2400 pixels wide, so what if I use 2400 pixels here? And I also reset x to 2400. Now we have this image that is 2400 pixels wide, scrolling endlessly over the canvas. And there is this black empty space that is also 2400 pixels wide. The trick people use is to simply draw the same image twice and always reset the one that has moved off screen so that it's available to scroll again and canvas is never empty. I will show you exactly what's going on using 2 separate x variables, one for each image, and then we will optimize it once we fully understand what's going on. On line 18, I have x variable which will serve as horizontal position for one of my background images. I will create variable I call, for example, x2. That's for the position of my second identical image. X will start at position 0 And on lines 24 and 25, I have my reset checks to make sure it cycles around endlessly. x2 will start where the first image ends. Since my images are 2400 pixels wide, x2 will be 2400. Images we are using today are very large. You might experience frame drops and lagging. If you do, you can make them smaller, but maybe if you can, just follow along with me till the end and then refactor your code and image files for performance, just to make sure we are looking at the same numbers at first. It makes it easier for you to debug your code if it's the same as mine. Once you fully understand this technique, you can use it for any image size and any scroll direction your game needs. On line 24, I just call draw image again for the same identical image, but instead of drawing it at position X from line 18, we will draw it at position X2 from line 19, like this. I also need to reset X2 the same way I'm resetting X. This is so-called spaghetti code. We have some code repetition here and it doesn't look very clean yet. I'm just doing it for complete clarity to show you what's going on. We will refactor it later. You will notice we have one problem when we do it this way, but don't worry, we will optimize it and fix everything. I want even beginners to understand. Now I can see some frame drops because my images are large, but I only see it on my screen recording software. It still runs smooth in my browser. Don't worry about the frame drops at this stage. It can be easily fixed by making our images smaller. Let's focus on the code first and make sure we understand it. You might notice there is a gap between my images. What's happening now? I have image 1 drawn at position X from line 18, and I have image 2 drawn at position X2 from line 19. The problem with this technique is that my images ignore each other. They reset based on two different variables, X and X2. These variables are completely disconnected, so if width of my image is not divisible by GameSpeed variable, it can actually happen that this gap between images will grow larger or smaller over time, and we really don't want that. We want endlessly scrolling, seamless background. Let's deal with it step by step. So what's this gap between my images? Why is it there, and how do I offset my images to get rid of it? Part of the gap is my game speed, because these if statements that reset X and X2 happen independently of each other. We have situations where X resets and X2 will move 15 pixels to the left for that frame. 15 pixels because that's what my game speed variable is set to on line 5 at the moment. They never reset at the same time because one of them is always visible on canvas. So when X resets, image 1 resets on line 25, or when X2, image 2 resets on line 27, I need to offset the other one by the amount of game speed to account for the fact that for that frame the other image kept moving while the other one was resetting. Gap is smaller now, but there is still a gap. Game speed is 15 pixels per frame, and my images reset when their X position is less than minus 2400. So unless 2400, which is my image width, is divisible by the current speed, with no remainder, there will always be some leftover pixels, creating a gap. This gap could even grow larger and larger as the scrolling and resetting continues. Some people deal with it by only allowing their game speed to be certain values so that image width is always divisible by game speed without any remainder. But we don't want this limitation. We want our game speed to be fully dynamic. Maybe you want your game to slowly go faster and faster as player progresses to more and more difficult levels. Or maybe you want to have special moves in your game, and when player performs these moves, you want them to affect speed of scrolling, like I do with this roll attack, for example. To do this, we just need to make sure that our X and X2 reset statements check position of the other image before they reset, and they offset its new position based on the current position of the other image. That way, even when gap is somehow created, it autocorrects itself next time around during the next reset. I do it by accounting for the current X2 position in my X reset check on line 25, and I account for current X position in my X2 reset check on line 27. Keep in mind that when these reset checks happen, x or x2 are small numbers somewhere around 0 at that point. This might be a bit tricky to visualize, and I know that some of you are already saying, Frank, what are you doing? There is a much simpler way to reset endlessly scrolling backgrounds using just one variable. There is no need for this x2 variable. There is no need for all this offsetting by speed and position of the other image to synchronize them. It can be done with much less code, and it is so simple. And if you already realized that, well done. You are good. Let me know in the comments if you are one of those people. I went through all of this to show you my process and to actually show you how it works. I didn't realize it can be done with one variable until I got to this stage when I was building the initial prototype. Also, I think everything we have done so far is really good for beginners to see what's going on and how this trick is achieved. We will clean this all up and optimize everything. But before we do that, let's animate all layers and make them move at different speeds. Parallax effect is when foreground layer moves faster than the background layer. It creates kind of a 3D effect, illusion of depth in a 2D space. It can be used in games, but it also looks really nice on websites. In our project, we will have 5 layers, 5 images, and I want each one to move at a different speed. At the same time, I want all the layers to be tied to the same game speed variable, so that when player performs special move, for example, the speed of all 5 layers is affected proportionately. How do we do that? Let me show you. First, let's check if all 5 layers are animated correctly. Everything is working, perfect. So how do I animate all of these layers at the same time? I guess I could just copy draw image on lines 23 and 24 and duplicate it for all 5 layers. Then I would have to create separate reset checks for their x and x2 positions to make sure they scroll at the different speeds. It's possible to do that, but there would be a lot of code repetition. Let's do it in a clean way. I delete x and x2 variable from line 18 and 19. I also delete all this code between lines 20 and 25. I will use JavaScript classes to create a blueprint for a layer object. Then I create 5 instances of that layer class, one for each of my 5 layers. I will put all of them inside an array, and I will be cycling through that array to update and draw them. It might sound complicated if you never used the JavaScript classes before, but don't worry, I will explain everything. It's actually quite simple. JavaScript classes are used when you want to create many similar objects. In our case, we will create 5 image layer objects. JavaScript class is a blueprint. I will define it, and then whenever I call it, it will create one instance of that object based on my custom blueprint. When I say it creates similar objects, I mean these layer objects will have shared properties and methods, but some of the properties will have different values. They will all have the same width of 2400 pixels. Each layer object will also have image and speed property, but each layer will have different image assigned to it and different speed value. That's what it means when I say similar. Same properties, but maybe different values. Let me show you how simple it is, step by step. We define class by using class keyword, followed by a custom name of that class, starting with a capital letter. I will call my custom class layer, for example. Each JavaScript class has one mandatory method called constructor. In object-oriented programming, when you say method, all it means is function attached to an object. Method is just a function. So this special mandatory constructor method has only one job. Whenever our class is called later, constructor will trigger itself, it will create one new blank object, and it will assign values and properties to that new blank object based on blueprint inside the constructor. Constructor runs only once per object, every time JavaScript class is called using the new keyword. I will show you in a minute. My constructor will expect 2 arguments. Image we want to assign to that layer, and speed modifier, because I want each layer to scroll at slightly different speed. We will pass these arguments from the outside when we create our 5 layer objects. I will show you in a minute. For now, let's finish our blueprint. The syntax might be a bit strange for you if you are new to object-oriented programming. Each layer object will have horizontal x-coordinate that starts at position 0. I say this.x because my layer class will create many similar objects, so I'm saying here on line 20, set x property on this particular object you are creating right now to 0. Because we are inside blueprint, that will trigger every time we call our class to create an object. I will also have vertical y coordinate that will be set to 0. All our layers will have the same width of 2400 pixels. Height will be 700 pixels for all my layers. X2 coordinate will be where we draw the second image. The second image needs to start where my first image ends, so at the horizontal position 2400 pixels. I know I said we could do this without X2 property, using just one variable. Let me just recreate what we had before as a class and then we optimize it together. I want to do this step by step for clarity. This.image equals image. This declaration is a bit different. What I'm doing here, I'm telling my constructor, create property called image on this new object you are creating right now and set it to image we pass as argument on line 19. I will show you how to pass arguments to constructor when the class is complete. I will do the same now with this.speed modifier. It equals the speed modifier passed on line 19 as an argument to my class constructor. This.speed will be how fast is my image layer moving. I will calculate it by taking my global game speed variable and I multiply it times this.speed modifier from line 26. Doing this will allow me to pass different speed modifier value for each of my 5 layers. And that way, each layer will move at a different speed, but it will still be tied to my global game speed. You will see in a minute. My layer object will also have access to custom method I call, for example, update. Its job will be to move layers horizontally by changing their this.x and this.x2 properties from lines 20 and 24, and it will reset them when the layers move off screen, the same way we did it before. We are doing the same thing we had before, but this time we are wrapping it in a reusable class syntax, so that we can do all of this at the same time for all 5 layers. We will also have a method I call, for example, draw. Its job will be to take information about this layer object and to draw it on canvas. Every time update method runs to change horizontal X position, draw will run again to redraw the image at the new position. To make sure my game speed is dynamic and always reacting to the current value of my global game speed variable from line 10, I need to recalculate this.speed like this. If you want your game to have a constant, never-changing scrolling speed, you don't need to do this line of code. Now I just say if this.x from line 20 is less or equal to minus this.width from line 22, so minus 2400 pixels, then set this.x to this.width plus offset it by the current position of my x2 minus this.speed. I'm just recreating the same thing we did before. I explained why I'm offsetting it by x2 and speed. It is to make sure there is no gap between my images. I copy this entire code block and I do the same thing for this.x2 property from line 24. So this.x needs to be offset by the current value of x2 and this.x2 needs to be offset by the current value of this.x. If they are not resetting, I just want my x property to decrease by the amount of this.speed from line 27. To make my background layer move to the left, I will wrap it in method floor to make sure we have no decimal points in there. Not sure if this is a good idea, let's see a bit later. I do the same thing for this.x2. This can be optimized and simplified, and we will do it in a minute. Now I can take these newly updated x and x2 coordinates and I draw 2 identical images next to each other, like we did before. So draw image built-in canvas method. I pass it this.image from line 25, this.x and this.y, this.width and this.height. Then I draw the same image, but I will draw it at this.x2 horizontal coordinate, like we did before. And that's it. Layer class is complete. We have a blueprint inside the constructor, and my layer objects have access to custom update and draw methods. Now I can create a new constant variable I call, for example, layer 4, and I set it equal to new layer like this. The new keyword is a special command in JavaScript. It will look for class with that name in our code, and it will trigger its constructor. On line 19, I can see that my layer constructor expects 2 arguments, image and speed modifier. I need to pass them here when I'm creating an instance of my class. So I will pass it background layer 4 variable as image, and speed modifier will be maybe 0.5. I want this layer to be moving at half of my game speed. So if my game speed is 10 pixels, this layer will be moving at 5 pixels per frame. Let's test it. So here on line 46, I call my layer class constructor from line 19. It created one new blank object for me and assigned it properties and values I defined in my blueprint between lines 20 and 27. Then it saved that new layer object inside this layer 4 variable. So this is how you create an instance of your custom JavaScript class. As we know, my layer class has access to update method from line 29 and to draw method from line 40. I can just go inside my animation loop. I can take layer 4 variable from line 46 and I can call update and draw on it like this. And here we go. We refactored our image layers into JavaScript class, and now it's very easy to work with it. I can pass it a different speed modifier on line 46 to make it move at a different speed. That speed is still relative to my global game speed variable from line 5, because I keep track of that on line 30 inside update method. I create variables for all my 5 layers. I will pass different images to each one. I could just call their update and draw methods by duplicating lines 54 and 55 like this. Now I'm drawing layer 4 and layer 5, but there would be a lot of code repetition if I did it for all 5 layers. If I change speed modifier value, I pass to layer class constructor on line 50, you can see their relative speed changes and we have parallax effect. Awesome. It is because that speed modifier takes game speed and adjusts it by multiplying game speed from line 5 times this modifier value. At first it happens on line 27 when the new object is created. Then it happens on line 30 whenever update method runs to make sure we can change global game speed dynamically, which we will do in a minute. Then we are just using this .speed property to recalculate horizontal exposition of our background images here on lines 37 and 38. And this is how you make your layers scroll at different speeds but still tie them together by using global game speed variable. Inside my animation loop, I can just call update and draw for all 5 layer objects, but I don't want any code repetition. I create a new variable I call, for example, game objects, and I set it equal to an array. I put layer 1 variable from line 46 in there, layer 2, 3, 4, 5. Now I have all 5 layers inside a single array, so on line 56, I take this game objects array and I call built-in forEach array method. ForEach method will simply run through all elements in the array and it will apply whatever callback function I give it to each of these elements, each of the layers. First, I need to declare how I want to refer to individual objects in game objects array within my forEach callback. I will refer to them as object, for example. I'm doing ES6 arrow function syntax here, where you can omit function keyword. So for each layer object, in my game objects array, I will call their associated update and draw methods, like this. Here we go, we are drawing all 5 layers now, awesome. Let's pass each layer a different speed modifier to create proper parallax effect. 0.2, 0.4, 0.6, 0.8, and 1. Now each layer moves at a different speed, but they are all still relative to our global game speed variable from line 5. If I change global game speed variable, it will affect all 5 image layers proportionately, because their speed is calculated by multiplying game speed times speed modifier. If you get any frame drops at this point, it is because we are using 5 images that are 2400 times 700 pixels. You will get much better performance if you make the images smaller in Photoshop or some other graphics editor. As you can see, I can change my game speed to any value and parallax background will still scroll based on that. I want to allow my users to easily change scroll speed. In index.html, I create a div with an ID of container. Inside, I will have paragraph tag that will say game speed, and span element with an ID of show game speed. This will show real-time value of game speed variable. I create HTML input element with type properties set to range. Min value will be 0, max value will be 20, starting value will be 5, class will be slider, for example, and ID slider as well. I put HTML canvas element inside the container. In style CSS, I take container. I give it position absolute with 800 pixels. I center it in the middle of the page using transform translate. I set canvas to position relative so that it aligns with container. I put border on the container so we see where it is. Input with an ID of slider will have width of 100%. Text color white. Okay, that doesn't work. I take paragraph tag and I move text color there. On container, I set font size to 25 pixels and I remove border. In script.js, I create a new constant variable. I call, for example, slider, and I point JavaScript towards my new slider element with getElementById. On the first page load, I will set slider value property, which is here, to GameSpeed variable from line 5. Then I take hold of this span element with ID of showGameSpeed and I save it in a variable I call showGameSpeed as well. On the first page load, I set its inner HTML equal to the current value of GameSpeed variable from line 5. If I change value of GameSpeed and reload page, you can see it works. Now I want to change scrolling speed of my layers when I click this slider. To do that, I need to connect it to GameSpeed variable from line 5. On line 22, I take slider from line 18 and I call addEventListener. We will listen for change event, and in callback function, whenever change event occurs on the slider, which means whenever user clicks on it to change its value, I will run some code. Callback function on EventListener has access to its built-in event object. I will refer to it as E here. I can refer to it however I want. JavaScript knows that the first argument passed to callback function on EventListener refers to this built-in event object. If I console log this E, you can see it gets console logged every time change event occurs on slider, and it contains a lot of useful information about that event. Right now, I'm interested in its target property, which references target of this change event, which is HTML input element with an ID of slider. When it gives me that, I can access its current value attribute, which is exactly what I need. If I console log e.target.value, it will give me the current value of this slider input element. I set minimum value to 0 and maximum to 20 here. All I have to do now is take GameSpeed variable from line 5 and I set it equal to e.target.value like this. And I will also update inner HTML in showGameSpeed span so that it displays the correct current speed for us. Now I can change scroll speed of my layers by clicking on slider. If I change it to max 50, we can get it to scroll really fast. I hope your computer can handle that. These images are too large. Let's set max value back to 20. You probably already realized earlier that we don't need to have this.x2 property here on line 33, and we can calculate position of both images using just this.x. That way, we don't need to have two separate reset checks here, and since everything is coming from just one variable, we don't need to do all this complicated offsetting we did earlier, because we don't need to make sure x and x2 are synchronized. If you want a little challenge, pause the video right now and try to refactor update method yourself by deleting all references to this.x2 and using only this.x to calculate positions of both images. If you don't know how to do it, don't worry. I also didn't realize it at first until I started working on this tutorial. I comment out line 33. On line 51, inside drawImage method, I replace this.x2 with this.x from line 29. I comment out this if statement and also this line 48. I remove reference to this.x2. Since I'm using this.x for both images on line 51 and 52, you can see our parallax has gap again. this time a big gap. Lucky for us, it's very simple fix. On line 52, I set horizontal x coordinate to this.x from line 29 plus this.width from line 31. That doesn't quite fix it yet, as you can see. I also have to look at my if statement on line 40. If this.x is less or equal to minus this.width, minus 2400 pixels, set this.x back to 0. If you don't understand what is happening right now, look at this. I have one image drawn at position x, which starts at 0, and the second image is drawn at position x plus width. These images sit next to each other and scroll to the left together, like this. When the first image moves past the left edge of canvas, the second image is there to fill the gap and make it look seamless. When the right edge of the first image hits the left edge of canvas, at the same time, this.x is minus 2400 pixels. Because my image is 2400 pixels wide, we will trigger reset. It will just jump back here and start scrolling again. The first method was controlling x coordinate for these two images separately by using this.x and this.x2 variables. We had to make sure it synchronizes correctly. Both images were moving independently, and I was offsetting them by their scroll speed and by the current horizontal position of the other image to make sure they stayed aligned. This is just a visual representation of what was happening. Of course, the transition itself, where the image resets after leaving the screen, was happening instantly. More like this. This second improved technique uses just one variable to move images horizontally. This image is at position this.x, and the position of the second image is calculated from that by adding this.x plus this.width. The second image is always 2400 pixels to the right of the first image. This way, they will always be synchronized since the position of both images is coming from the same variable. As you can see, the movement is different now. We never actually fully see the second image anymore. We just see this small part that pops in place so that it looks like it's one long seamless image. Again, the transition, the reset where the images move to the right to start from their original position, happens very fast. It happens instantly, so we jump from this to this. And that makes it look like it's just one seamless movement. We can also calculate position x differently. I can create game frame variable and I set it to 0. Then in my animation loop here on line 65, I increase game frame by 1 for every animation frame. This way we have a number that is endlessly increasing. Now I can replace this if statement on line 40 with a different calculation. When I remove this if statement completely, the backgrounds no longer reset when they leave the screen. I also comment out line 43 and I can replace all of this with just one line of code. I say this.x from line 30 is equal to game frame variable we just created, and I use remainder operator and this.width from line 32. This.width is currently 2400 pixels, and game frame is endlessly increasing number. This calculation will make sure this.x cycles endlessly between 0 and the value of this.width, between 0 and 2400 pixels, which will have the same effect as we had before. Oh, it will go to the right. I need to do game frame minus minus on line 66. That's better. But now all our layers are moving at the same speed. I need to factor in this.speed from line 36 in this calculation on line 44. This.x equals to game frame times this.speed modulus this.width. Now we have the same parallax effect. This one line of JavaScript replaced all the code between lines 40 and 43. I don't think it's very clear and easy to see what's happening on line 44 just by looking at it. I really have to use my brain and remind myself how modulus operator works to understand why it's cycling between 0 and this.width. I did a complete breakdown of this technique in my sprite animation video. I will link it in the video description. I'm not going to explain this calculation all over again. I don't think we need to understand this line because it has one disadvantage when compared to the code I had previously on lines 40 to 43. Look, when I change scrolling speed, the position of background jumps somewhere else, because we aren't gradually increasing this .x like we did before. We are recalculating that value completely every time game speed changes. Clicking this input slider changes game speed global variable. Changing game speed affects this.speed because of line 39, and this.speed changes value of this.x on line 44. If you know how to use this technique to make it seamless without jumps in horizontal position when I change game speed, let me know please. I'm sure there is some smart way to do it. I played with it for a while and I couldn't work it out. Do you see how the background jumps every time I change game speed? Let's comment out these lines so that we can compare it. When using the original technique, horizontal position transitions smoothly without jumps, and that is exactly what I want. I need to be able to change my scrolling speed dynamically because I want the scroll speed of my game to change when a character performs special moves, like roll or sit. Let's comment out line 66, since we decided not to use this technique, and I also comment out line 6. Our images are large. It works well because I'm running my code locally. If this codebase was hosted somewhere online, we need to make sure all images and HTML elements on my page are fully loaded before we start the game. On line 19, I take browser window object and I call add event listener on it. I listen for load event. In callback function, when the page is fully loaded, only then I will run all this code. That depends on images, canvas and slider element to be properly loaded and available. In this video, we will build 4 small projects completely from scratch. We will learn how to generate groups of animated computer-controlled characters for our games, and we will explore 4 different movement animation patterns. I went to the forest and I caught some dangerous magical creatures for you. Today we will study them and learn how they move. Some of them have wings, some of them spin around, and some just float in the air. It will be interesting to explore their movement patterns. This is Creative Coding Tutorial for Beginners. Let's learn fundamental vanilla JavaScript principles and techniques by building fun projects together. Hope you get a lot of value today. Art for this episode was made by this amazing artist. Go check out his website if you want to see more. We will cover 4 different movement animation techniques, and by the end of this video you will have 4 complete projects, and you will be able to introduce a variety of different enemies and movement patterns to your personal JavaScript games. Sometimes we tend to make our games too easy and predictable. Let's give our players some challenge by including different enemy types. I create a simple web page markup, I give it some title, I link style CSS file in document head. We will draw everything on canvas, so I create it here and I give it ID canvas1 so that we can target it with CSS and JavaScript later. I also link my script.js file, which will contain all animation logic. In style CSS, I take my canvas element I just created and I want to give it some border, size, and I want to center it in the middle of the page. So border 3 pixels solid black, position absolute, top 50%, left 50%, transform translate -50%, -50%. Now it's in the middle. Let's make it vertical, so height 1000 pixels. Width will be, for example, 500 pixels. Everything else will be drawn with code in the script.js file. This is a beginner tutorial, so don't worry, I will take you through it step by step. As with every canvas project, I need to point JavaScript towards my canvas element we just created in index.html. I do it by using getElementById, and I pass it ID I gave my canvas element, canvas1, like this. CTX, shortcut for context, is equal to canvas.getContext, and I pass it 2D. We will use a built-in set of 2D drawing methods today. Now I can call all these built-in methods from my CTX variable. If I type CTX dot like this, you can see that in VS Code Editor, my autocomplete feature doesn't suggest any built-in canvas methods. If I want them to be suggested, I can go up to line 1 and type @type HTML canvas element like this. This way I tell VS Code this is a canvas project and it will suggest built-in HTML canvas methods for me. You can see arc method here to draw a circle, clear rectangle to delete paint from canvas, and so on. We will use some of these in a minute when we start drawing and animating, but first let's quickly finish canvas setup. We need to set canvas width and height to make sure we get correct scaling of our drawings. So I create a custom global variable called canvas_width. I set it equal to canvas from line 2 dot width, and I set it all equal to 500. Canvas_height is canvas.height is equal to 1000. These values need to be the same I gave it in style CSS. I want to create a factory function that will produce many similar objects for me. Each of these objects will be one animated enemy. Before we create many enemies, let's just build one and make it absolutely clear for beginners what's going on. When we have that, it's easy to scale it up. I will create a temporary enemy1 variable and I set it equal to JavaScript object. I give it x and y properties and I set them to 0. These will represent horizontal and vertical coordinate on canvas where we draw that enemy. I will also give it width of 200 pixels and height of 200 pixels, like this. So now I have this simple JavaScript object that is storing position and size of one enemy. Let's animate it. To create animation loop, I like to write a custom function I call, for example, animate. Inside I call built-in fill rectangle method. This method expects x, y, width and height of the rectangle we want to draw, so I will give it x, y, width and height of this enemy object. When I call animate like this, we are drawing a black rectangle representing the enemy object. I can change its values, and when I refresh the page, it will be reflected on canvas. We are not animating yet. What if I want the horizontal x position to be slowly increasing to make the enemy travel to the right? I can say for each run of animation loop, increase enemy1.x property from line 8 by 1. To create animation loop, I call built-in request animation frame method. I pass it animate. Now animate will run all its code and then it will call itself again. This will create an endless animation loop. I also need to delete old paint, previous frames from canvas. I do it by using built-in clear rectangle method and I clear canvas from coordinates 0, 0 to canvas width, canvas height. Now we see only the current animation frame. I can also increase vertical Y position by 1 for every frame, so we get movement towards bottom right, like this. I can change width and height of my enemy easily. You get the idea, I think. Let's comment out this temporary enemy object and make it into a JavaScript class, so that we can generate a large number of enemies at once. JavaScript class is kind of a template to create many similar objects. It's a factory, and every time we ask it, it will produce one new object for us, based on a blueprint we give it. Classes are a new syntax for older JavaScript prototypes. Under the hood, it's the same thing. It's just so-called syntactical sugar. Simpler, nicer way to do the same thing. Classes are very easy and intuitive. Let me show you. We use class keyword and then we name our class starting with a capital letter. My class will be called enemy. Constructor is a mandatory method every class must have. It will contain a blueprint based on which every enemy object will be created. So here in constructor, I just give it x, y, width and height, same as we had in this simple enemy object on line 7. The syntax might be a bit strange at first. Here I'm telling my constructor, on this new enemy object you are creating right now, give it property called x and set it equal to 10 pixels. Starting vertical y coordinate will be 50 pixels, width will be 100 pixels and height 100 as well. So this is how you recreate single JavaScript object into a reusable class. Now we can call our enemy class as many times as we want, and each time it will generate one new enemy for us, based on a blueprint inside constructor method between lines 16 to 19. I can delete the old code, and now these variables are undefined because enemy1 doesn't exist. So I create a new constant variable called enemy1 again, and I set it equal to an instance of my new enemy class. To do that, I use the new keyword followed by a class name. The new keyword will simply look at that class name in my code, it will enter its constructor, it will create one new blank JavaScript object, and it will assign it values and properties based on a blueprint inside the constructor. Now, my fill rectangle method on line 21 can use these values again to display a rectangle. What if I want another enemy? I can create another variable called enemy2 and I set it to new enemy again. Inside animation loop, I take enemy 2 and I increase its x and y coordinates as well. And on line 25, I need to draw another rectangle representing that enemy like this. They are moving at the same speed in the same direction, so we can't see the second one. Let's adjust its speed, for example. Now we can see that there are 2 of them. We can control them separately like this, but this wouldn't be very efficient if we had, let's say, 50 or even 500 enemies. So how do we make this code better and remove repetition? First, let's output this code between lines 21 and 24 that handles movement along x and y axis into a shared class method. That way, we can write this code only once and it will be available to all objects created by enemy class. I will call that custom function, for example, update, and as I said, its job will be to update coordinates of my objects. It will handle position calculation and movement. So inside I say for every frame increase x by 1 and also increase y by 1. Let's delete all this code, and to run update method I just created, all I have to do is call enemy1.update like this. Since enemy1 object was created here on line 19 as an instance of my enemy class from line 7, it automatically has access to this new update class method from line 14. I also need to remove line 25. So now we put all movement calculation functionality into this update method. I also want to put this drawing code into its separate method so that we can draw all enemies at the same time. We can also give them animated sprites and so on. I will show you in a minute. On line 18, I create a custom draw method. Inside, I call ctx fill rectangle, the same way we did here on line 27, but instead of hard-coding enemy1 object here like this, I will use this keyword. That way, this method will be reusable and can animate not only enemy 1, but also enemy 2, enemy 10, enemy 100. It can animate all the enemies created by this class at once. On line 27, I can replace these hard-coded values with enemy1.draw. It will look the same, but now it's reusable and scalable. Inside constructor, between lines 9 and 12, all enemies start at the same x and y coordinates. So if I create 50 enemies, they would all stack on top of each other and wouldn't be visible. Let's randomize that. Every time I create a new enemy, its horizontal x coordinate will be a random number between 0 and canvas width. And vertical y coordinate will be a random number between 0 and canvas height. Now, every time I refresh page, my enemy appears at a different position. I could also randomize width and height if I wanted to make each enemy random size. I think you get the idea. So how do I create many enemies instead of just one? I comment out line 22 and I create a for loop. This for loop will run, for example, 100 times. Actually, let's go up to line 6 and create a constant variable called the number of enemies, and I set it to 100. And I replace hard-coded 100 on line 24 with this new variable. That's better. We shouldn't be hard-coding values if we can avoid it. I want this for loop to run 100 times and create 100 enemies for me using my custom enemy class. But how do I store all these enemy objects and their properties, such as their x and y values? I can, for example, go up here to line 7 and create a custom variable called enemies array. And I set it equal to an empty array. Down here on line 26, I take that enemies array and I call built-in array push method. Push method will just take whatever we pass to it and it will push it to the end of the array. I pass it new enemy. Every time this for loop runs, and it will run 100 times, it will create one new enemy using my enemy class constructor, and it will push that new enemy into enemies array. It's the same as we did with enemy 1 on line 24, but here we are doing it 100 times. Let's delete line 24. I also have to comment out lines 31 and 32 because enemy 1 variable doesn't exist anymore. How do I access all these 100 objects I just pushed into my enemies array? And how do I trigger their update and draw methods one by one so that they can be animated on canvas? First, let's console log enemies array to make sure that for loop on line 25 did its job and filled it with 100 objects. In console I can see we have 100 enemies and each one has randomized x and y coordinate. Perfect. So as I said, the goal now is to cycle through all 100 enemy objects inside enemies array and to trigger their update and draw methods. This will need to happen for every animation frame over and over, because we need update method to constantly recalculate enemy position and the draw method to draw them at that new position. On line 33 inside animation loop, I take enemies array that contains my 100 objects and I call built-in array for each method. For each, simply calls provided callback function for each element in the array. I will use new ES6 syntax with arrow function here. Inside my for each callback, refer to each individual object as enemy as you cycle through enemies array. And for each of these objects, call their associated draw method and also their update method, like this. Perfect. You can see that each rectangle appears at randomized X position and they all move in the same direction because of lines 17 and 18. What if my enemy had randomized speed? I create a new property called this.speed and I set it equal to a random number between -2 and +2 because I want some of them to go to the left and some of them to go to the right. If you find it hard to read this line of code as a random number between -2 and +2, think of it this way. This part of code generates a random number in this range, so between 0 and 4, and this number sets the start of that range. So we are generating a random number between 0 and 4, but we are pushing that range to start from -2. So result we get is a random number between -2 and +2. I remember I always found math.random very unintuitive until I found a better way to think of it. Anyway, now I have this.speed property and I can replace it here on line 18 for horizontal position and also on line 19 for vertical position. Now you can see we have rectangles moving in many different directions. I delete code on line 29 and also on lines 32 and 33. On line 21, inside the draw method, our enemies don't have to be represented by a black rectangle. We can write any drawing code here and it will be called and replicated for all enemies at once. I can, for example, try stroke rectangle instead. We can also draw circles, stars. You can put selfies from your holidays to represent each enemy object here. We have complete flexibility. What I want to do here is to create animated creatures, because we want these to be enemies for our JavaScript games. With this video, we are giving away 4 different animated enemies, drawn by this amazing artist. Go check out his website for more content, he is very talented. He allowed me to share these sprites with you for educational purposes for free. You can download them in the video description, and you can also find link to his website there. If you want to use these sprites for commercial purposes, you would have to go to his website and buy a full license. They are free only for purposes of this educational video. Show him some support if you can. We don't have many good 2D artists like this. If we support them, they will be able to create more beautiful game art assets for us. Today we will create 4 different projects. Each one will have different enemy with a different movement pattern, and on each one we will demonstrate different beginner-friendly movement animation technique. I want you to always have a nice complete project at the end of my videos, so that you have something to show to your friends or on your coding portfolio. It feels good to complete something, don't you think? You can use these as animated backgrounds or a screensaver, or you can take this code and slot it into your personal games. It will be compatible with my previous games if you followed these tutorials. Let's start with a very simple one. The first project will have bats flying in random jumpy patterns, perfect for Halloween game or even a website, for example. I'll leave the creative applications of this on you. First, I need to bring new image into my JavaScript project. To do it, I create a custom variable called enemyImage and I set it equal to new image. enemyImage.src is equal to enemy1.png if you are using the same sprite sheet I'm using. It might be a good idea to use the same files at first and follow along, and once you understand the code, it's easy to adjust it and to use your own custom images. On line 26, inside the draw method, I call built-in drawImageCanvas method. We will use it to animate our bat sprite sheet. I will explain sprite animation quickly as I code, but if you need more detailed explanation, I made a special video where I focus on it in depth. I will link it in the video description. ctx.drawImage, and I pass it image I want to draw, and I pass it x and y coordinates. And this is what we get. We can also pass it optional width and height arguments, which will scale the entire image into that specified size. You can see it pushes the entire sprite sheet with all 6 frames inside the rectangle. We don't really want that. We only want to crop out 1 frame at a time, and we want to be jumping by the amount of sprite width to the right to display the next sprite frame. We want to go frame by frame from left to right until we reach the last frame. Then we want to jump back to the first one and start again. We can do this with the draw image method because it offers additional 4 optional arguments we can pass to it. Let's go up inside enemy constructor to create a property called sprite width. I check my sprite sheet, divide its width by the number of frames, and I can see that width of a single frame is 293 pixels. Sprite height of this particular sprite sheet is 155 pixels. Now let's add additional 4 arguments to draw image method to tell it what area we want to crop out from this sprite sheet to display only 1 frame. Let's start by displaying just frame 1. So I want to crop out area from coordinates 0, 0 to coordinates sprite width, sprite height. Now we are drawing just frame 1. So in this version of draw image method, we are passing it 9 arguments in total. The first is the image we want to draw. The next 4 represent the area we want to crop out from the source sprite sheet. And these last 4 arguments determine where on canvas we want to place that cropped out frame onto. You can see my bars are slightly distorted because I'm stretching them to fit this dot width and this dot height here, which are unrelated to the actual dimensions of my bat enemy character. Ideally, I want to preserve the aspect ratio, so I make width and height relative to the sprite size. I take width and height and I move them to go after sprite width and sprite height so that they can see these values. Now I can make width 1/3 of sprite width and height 1/3 of sprite height. Now our bats are the correct ratio. Maybe I want to make them a bit larger. Let's try 2.5. That's better. Right now we are displaying only frame 1 because of these hard-coded 0, 0 coordinates. Let's cycle through all frames and animate our characters. On enemy class, I need a new property called this.frame and I set it to 0. On line 30, instead of hard-coding horizontal coordinate 0, which will give us this frame, I will take this.frame variable and I multiply it times this.sprite width. That way, when frame is 0, we display this frame. When it's 1, we display this frame, 2, 3, and so on. So now all I have to do is that frame cycles between this and this frame, between 0 and 5. I will use ES6 ternary operator, which is a simple one-line if-else statement basically. I say if this.frame is more than 4, question mark, set this.frame back to 0. Else, colon, increase frame by 1, this.frame plus plus. This should be colon. Our bats are flapping their wings and animating, but they flap very fast and all of them flap at the same time. Let's fix that. There's a proper way to time animation frames using request animation frame and delta time, and I will show you how to do that in some other video. Today let's slow down our animation the simplest way possible. On line 11 I create a variable called game frame and I set it equal to 0. Inside animation loop on line 46 I increase game frame by 1 for every loop. And up on line 28, inside update method, I say if this ever increasing game frame variable is divisible by, let's say, 2 with a remainder of 0, only then serve a new animation frame. This line simply means run this code only every 2 loops of main animation loop. If you are getting a little unsure, I made a special sprite animation video where I go in depth and slowly over all of this. For now, let's just move on and focus on movement patterns. Now, bats animate slower, but they all still move their wings at the same time in the same rhythm. I want to randomize their animation frequency. I create a custom property called, for example, flap speed, and I set it equal to a random number between 1 and 4. I replace hard-coded 2 on line 29 with this randomized flap speed value. This will make some of them animate very quickly, some of them slower. Some will animate every 1 or 2 or 3 or 4 frames. it will be randomized. The reason it doesn't work is because math.random returns numbers with decimal points, so GameFrame is never divisible by that very specific number with a remainder of 0, and frames never increase. To fix that, I just need to wrap it in math.floor. Now, some bats flap their wings slower and some do it very fast. I will remove the stroked rectangle. I can also take enemy image variable from line 9 and actually make it a property on JavaScript class like this. This.image equals new image. This.image src source is enemy1 png. I delete that. And inside draw image on line 34, I refer to this.image instead. By changing value of number of enemies on line 6, we get a different number of bats in our project. Currently, our bats just fly away from canvas and never come back. We don't really want that. Let's create the first, simplest movement pattern, which will simply be just randomized, jumpy, chaotic movement. I comment out this.speed on line 17, and on line 26 I replace it with math.random times 3. I do the same with this.y on line 27. Since we are adding positive numbers to x and y, all bats are going to leave canvas like this. How about we tried a random number between -1.5 and +1.5. Now they kind of stay in place and just wiggle around. We can increase their wiggle by giving this random number a larger range, for example between +2.5 and -2.5. I can see that my initial enemy x and y coordinates are not 100% within canvas. Let's adjust line 15 like this. And since I'm using this.width here, I need to move it after this.width has been declared. Now, they initially spawn within canvas horizontally. These brackets are important. Look what happens when I remove them. They just start from minus this.width, which is wrong. These brackets need to be here. Let's do the same thing vertically for this.y. I reduce the number of enemies to 100, or 10. Let's make the range much larger on line 26, between -7.5 and +7.5. I can just play with these values and get a random simple jumpy movement. This is the simplest way you can animate enemy characters or NPCs for your JavaScript games. We will do 3 more, adding a little bit more complexity each time. Let's see what comes out of that. I will be expanding, deleting and adjusting the same codebase, so if you want, maybe it's a good idea to create a copy of this project at this stage, so you have this movement pattern saved in case you want to use it for your games later. I will be using different enemy sprite sheet and different movement pattern for the next one. I hope you're having fun! For the second movement pattern, we will do something a bit different. First, let's switch to a different sprite sheet here on line 14. I will use image I called enemy2 png. It's different size, so I have to change sprite width and sprite height. Sprite width is 266 pixels and sprite height is 188 pixels. I uncomment this.speed on line 15 and I give each game character a random speed between 1 and 5 pixels per frame, for example. On line 26, I set this.x to be equal to minus this.speed. If I comment out y, we can see that bats just fly to the left in a straight horizontal line, and they never come back. Let's first do a reset check. If this.x from line 20 plus this.width from line 18 is less than 0, meaning when the character moved behind the left edge of canvas and is completely hidden, that's why I included this.width here. When that happens, I want its horizontal x position to be reset back to canvas width, moving it behind the right edge of canvas so that it can do another flyover. Now we have endless right to left movement. Awesome. We already have something interesting here, but what if I want them to sway up and down as they flap their wings, making it a bit more dynamic? And if these were enemies in my JavaScript game, maybe it would make it a bit more difficult for a player to avoid them. How do I create wavy movement? Do you know what sine wave is? Let's do a little bit of very simple, beginner-friendly trigonometry. Trigonometry is a branch of mathematics that studies relationships between side lengths and angles of triangles. We use it to create wavy and circular movement in our JavaScript animations thanks to built-in JavaScript math methods. Today we will have a look at math.sine and math.cosine built-in JavaScript methods. Sine is a trigonometric function of an angle, defined in a context of a right triangle. All we need to know for now is that math.sine returns the sine of a number we pass to it. That number represents angle value in radians and it returns numeric value between -1 and +1. So this input angle value it takes, if I put it inside animation loop and slowly start increasing it over time by very small amounts, when I pass this angle value to math.sine, it will return a series of values that endlessly cycles between -1 and +1, making it easy for us to convert these values into wavy movement, so-called sine wave. What I just said might be a bit complicated for beginners and it might not make much sense yet. Let me show you. I will need this .angle property on my enemy class constructor, and I initially set it to 0. This is the number that will be increasing, and after being passed to math.sine, it will give us that series of values between -1 and +1, as I just mentioned. Let's do it so you can see. On line 28, I set position y plus equals math.sine, and I pass it this .angle. Then I increase this .angle by 0.1 for every animation frame. As the angle slowly increases, do you see the waves? I can change the value here on line 29 to change shape of my sine wave. Angle doesn't have to start from 0, it can be a bit randomized. Let's try with math.random times 2. It will not be very visible. It will become clear what it does a bit later, I will point it out. Quickly set starting value of this .angle determines what position along the sine wave this particular character appears at first, before it starts moving. It's more obvious if we map movement to a circle, and we will do that in a minute. I can also randomize the speed at which angle value increases on line 30. I do that by creating a new property called, for example, angle speed, and I set it to a random number between 0 and 0.2. Then I take this variable and I replace this hard-coded 0.05 with it. Now, each enemy has its own angle value that is being increased by a slightly different amount for each frame. This will randomize the wave shape for each enemy. Let's set this .angle to 0 for now. I reduce the number of enemies on line 6. As I said, math.sine returns values that cycle periodically between -1 and +1. What if I want to make the curve more prominent? I can simply just multiply it times 3 here on line 29, and now we are getting values that cycle between -3 and +3. Do you see how the sine wave of enemy movement is more prominent? Look what happens when I put different numbers here. I hope it's becoming more clear what I'm doing. If I put times 10, we get a very prominent curve. If these are enemies in your game, good luck to all players trying to avoid them. Especially for certain sprite sheets, this movement might be very suitable. Maybe you have some strange aliens in your space game and you want to move them in this weird wavy pattern. Instead of hard-coding number 10 here, I can again put this value in a variable that will be randomized for each enemy. That way we get even more variation in movement between enemies. I will call it this.curve, for example. Sorry about my variable names, sometimes it's hard for me to come up with suitable names for all these custom properties. I hope it's becoming at least a little bit clear what each of these properties does so far. I want curve property to be a random number between 0 and 10, and I replace this hard-coded 10 with it, here on line 30. Maybe 10 is too much. Let's do times 7 here on line 26. Do you see what we just did? Some of them move in a very prominent waves, some have barely any vertical movement. This would make our game more unpredictable. I can add as many enemies as I want. Let's put 200 here on line 6. Haha, bat infestation. This will be a hard mode in my game. So we did endless horizontal movement with vertical sine wave element to it. What if we bring it a step further and also add some trigonometry for horizontal x coordinate? We can make the enemies move in all kinds of different shapes and patterns that way. Let me show you. As usual, I will first swap to a different image. On line 14, I set image src to enemy3 png. I check my sprite sheet and I see that width of a single frame is 218 pixels and height is 177 pixels. Let's comment out lines 29 and 30, which will stop our character from moving around. On line 29, I want horizontal movement to be cycling within a certain range. I call method sign and I pass it this.angle from line 24. This.angle value is increasing over and over on line 31 as update method is called from inside animation loop. I will also multiply it times method pi divided by 180. Let's just experiment here a bit. If I multiply this whole thing by 10, nothing happens. 50. We see some movement. 100. Yes, they are moving now. This angle speed on line 25 affects how fast angle value on line 31 is increasing. If I set it to 0.9, they will move faster. Times 2 might be a good speed for now. They kinda disappear behind canvas edge. I can move them by adding some value to this.x position like this. Plus 10 will move everything slightly to the right. Plus 100. How about plus canvas width divided by 2? I want to center them horizontally. Now they are too much to the right. I need to offset them by the amount of their width. I change this dot curve on line 26 to be a random number between 0 and 200, and I replace hard-coded 100 on line 29 with this dot curve property. Now some of them move in a large range, some only in a small area. As we said before, method sign, when we feed it an angle, it will return a value between +1 and -1. Since this angle is ever increasing on line 31, we are getting a continuous series of values that endlessly bounce between -1 and +1. By multiplying all of this by this dot curve here, for characters that have this dot curve 200 for example, they are endlessly cycling between -200 and +200. Put it in brackets. Actually, this has to be this dot width divided by 2. Yeah, now they are centered horizontally. On line 29, we are animating horizontal X position. Let's also do this with this dot Y on line 30 and see what happens. If I copy the same formula and replace width with height, because we are dealing with vertical movement, we get this pattern. This is where cosine comes in. I'm not going to explain trigonometry in detail in this video, but the main idea is you have a circle and radius of that circle can represent hypotenuse, the longest side of a right angle triangle. If we connect lines like this to complete the triangle, sine value represents relationship between opposite side of the triangle and hypotenuse. Cosine is the relationship between the adjacent side of that triangle and hypotenuse. Hypotenuse size never changes, but sine and cosine cycle periodically as the size of opposite and adjacent side of this imaginary triangle changes. As a result, sine and cosine complement each other to map a circular path, and that's what we are taking advantage of here. Method sign is creating periodical horizontal movement for me on line 29, and on line 30, method cosine is doing that for vertical values. Together, they complement each other in a way that results in a circular movement. You can play with these values, swap sine and cosine, make both of them sine or cosine. It should illustrate it better what's going on if you see how these changes affect our animation. If I want to have some space in the middle, we know that this dot curve determines radius of the circle my characters are moving in. That value is randomized for each one. I can give it a minimum value. For example, let's do a random number between 50 and 250. I can also change angle speed on line 25. This will affect how fast angle is increasing on line 31, and because that angle is being passed over and over to method sine and method cosine, it will increase that speed at which our characters move along the circular path. See, here we already have some interesting movement pattern for our enemies. I could use this in some parts of my game. Right now, sine and cosine are even. What I mean is, they cycle between the same set of values over and over, which results in even circular movement. What if I make the horizontal position to cycle at half the speed compared to vertical position by saying method pi divided by 360 here? Now, vertical position does 2 cycles, while horizontal position does only 1, because of the difference between 360 and 180. These two values here. This will give us a different movement pattern. If I give both of them the same number, it will be a circle. Smaller numbers will result in a faster movement. The resultant movement is always a relationship between these two values. These values don't have to be directly divisible by one another, but it might help to visualize it better. For example, here horizontal position will go over 5 cycles, while vertical position will do 1 cycle. It's because of the relationship between 90 and 500. It gives us interest in movement. I can change their speed also by adjusting this .angle speed on line 25. So this technique can be customized to achieve movement pattern you are looking for. Maybe your game starts easy, but later it becomes more difficult, so you need faster enemies. If I put 360 here, 360 is divisible by 90. If you watch the animation, we will get 4 horizontal cycles before we get 1 vertical cycle, because 360 divided by 90 is 4. Don't feel like you have to fully understand sine and cosine at this stage to take advantage of this technique. I will make a special video where we deep dive into this functionality. For now, this is all we need to know to be able to use this for our games. If I want the shape to be number 8, I can just make vertical value double of horizontal value here. I can play with different numbers and see what happens. I can also have cosine for both like this. It will cause them to backtrack, to go back and forth following the same path, rather than moving in circles. Swapping sine and cosine will make our characters follow circular path in the opposite direction. I don't like how they fill the entire width, but they don't fill the height of my canvas. How do I make them use all available space? We are using this .curve, which is a random number between 50 and 250, and it makes them move within that range. What if I replace it with canvas width on line 29? Okay, that's too much because this value is radius of their movement, half circle. If I want them to cover width of canvas, I need to give them canvas width divided by 2. Much better. Let's do the same for vertical position on line 30, canvas height divided by 2. Awesome, now our movement path is even more obvious. I will increase number of enemies on line 6, just so that we fill the path with more objects and see it better. Now you can clearly see that our enemies are running along a set path. Shape of this particular path is determined by relationship between 90 and 270 here. 3 horizontal cycles fit into 1 vertical cycle, because 270 divided by 90 is 3. If I make the values the same, we get circular path again. It's an ellipse because I'm stretching the movement here and here. 180 in X and 90 in Y will mean 2 vertical cycles happen before we get 1 horizontal cycle. What happens if I swap 180 and 90? Interesting. To get 8 shape, I would have to swap sine and cosine here. Are you starting to understand how these values affect the shape of path our animated characters take? You can play with this for a while, experiment with different values and see what happens on canvas. Trial and error can sometimes be the best way to come up with unique, interesting results. Trigonometry is a big topic and we will come back to it in some other course. I'm sure some of you get other ideas for this technique. It doesn't have to be used for patrolling enemies in games as we are doing here. You can, for example, use it to create automatically moving particle effects and animations for website and many other things. Creative coding gives us a lot of opportunities to come up with unique, beautiful stuff, and that's why we are building these projects together to improve our vanilla JavaScript skills and at the same time to explore what's possible. Maybe it will spark new ideas in some of you. I know that there are many creative people watching my videos. I'm just here to give you the tools. Where you take it and how you decide to use it is up to you. We can play with these values and create different paths. This .angle property on line 24 determines where along our path our animated characters appear at first. I can spread their starting position along the path by using math.random. I could have also used something a bit more unusual like oscillators or Perlin noise here, but I want to keep this video beginner friendly. We can do more advanced path following and random movement algorithms later. Another simple technique uses a completely different trick, and it results in what I think is the best movement pattern if you want your enemies to appear like they have mind of their own, at least when we stay in the world of simple beginner algorithms. There are many advanced AI techniques you could use, but this is JavaScript for beginners. You might want to make a copy of this codebase, because to achieve the next effect, I will break this one a little bit. Let's delete lines 24, 25 and 26. I will also set this.x and this.y to 0 inside my update method. And I delete line 28. I comment out lines 26 and 27, and now initial x coordinate is randomized on line 20 and vertical coordinate is randomized here on line 21. I will create a new property. I call, for example, new x, and I set it to random number between 0 and canvas width. I do the same for vertical y coordinate with this.newY property. So I have initial horizontal position on line 20 and I have new horizontal position on line 22. On line 9 I have GameFrame variable that is endlessly increasing inside my animation loop. I will say every time GameFrame is divisible by 30 with a remainder of 0, which basically means every 30 frames of my main animation loop, I want to reset this.newX and this.newY to a different random position. Basically, I just need to copy lines 22 and 23 here. Now, I will calculate variable I call, for example, dx, distance on horizontal x-axis. It simply is the difference between this.x from line 20 and this.newx from line 22. dy, distance on vertical y-axis, is this.y from line 21 minus this.newY from line 23. Now that we have distance between current position and the new position, I can make characters move towards that new position by saying this.x minus equals dx from line 32 and this.y minus equals dy from line 33. It's resetting too fast. Let's change 30 to 60 here on line 28. Now we get instant position change every 60 frames. I can make them travel towards that position by saying dx divided by 20. I can also do that for vertical position by saying dy divided by 20 here. Now, current position is always moving towards the new position by 20th of their distance for every animation frame. I can increase these numbers to make them move slower. I can also increase the interval on line 28. I like this, but you can see that positions reset every 100 frames for all enemies at the same time. That looks a bit weird. I want each character to reset at its own randomized interval. I create a property I call, for example, this.interval, and it will be a random number between 50 and 250. Then I replace hard-coded 100 with this.interval on line 29. It won't work yet because this.interval is a random number with decimal points, so GameFrame will never be divisible by that very specific number with a remainder of 0, so new positions will never be calculated. To fix that, I need to wrap this in math.floor, which will round it down and make sure we get only integers, whole numbers without decimal points. Awesome! Now you can see that each enemy is moving at their own rhythm. I can add more enemies on line 6. It kinda looks like a swarm of mosquitoes. I also need to swap enemy sprite sheet to keep up with tradition. I will use enemy 4 PNG here. I look at my sprite sheet and width and height is 213 pixels this time. There are many other calculations and algorithms that you can use to make enemies move in a certain way. Let's make that today's challenge. Can you alter some of the code we wrote today and create your own movement pattern? You can also make enemies follow the mouse or maybe try to avoid it. There are many ways to make this interactive. Let me know in the comments if you watched all the way here. If you did, well done. Today we added an important set of techniques to our vanilla JavaScript game development toolkit. I'll see you soon. If you want more game development, check out my playlists. Links in the video description. Collision detection is important if you want to build JavaScript games and you need to detect when two elements collide. Or when you are building particle systems where objects interact with each other. Or maybe you want your canvas animations to interact with regular website elements. For most projects, all we need is simple collision detection algorithm between two rectangles or between two circles. For more complex shapes, we also use collision detection technique called separating axis theorem. It can be used to detect collision between convex polygons or rectangles that are rotated and aren't axis aligned. You might also have more specific needs for your games or creative coding projects. Some of other common scenarios are collision detection between point and circle, point and square, between line and circle, line and square, between two lines, and so on. It becomes more complex when you need to detect collisions where shapes such as convex and concave polygons are involved. There are some clever tricks people came up with to handle these more advanced scenarios, such as detecting collision by color or projecting lines from a point and checking if the number of intersections between that line and polygon is odd or even number. With more complex shapes, it's a good practice to wrap them in simple rectangles and only run advanced collision checks if these rectangles collide and we know that the shapes are close enough and collision is possible. For many games, all you need is to create a generic shape around our objects, so-called hitbox. Even though the collision is not pixel perfect, we can adjust these hitboxes to roughly match collision areas of objects with different shapes. Main advantage is that the code is very simple and performant, because it doesn't require complex calculations to determine whether two objects collide or not. These hitboxes can have shape of rectangle, circle, or polygon. The simplest collision detection algorithm is between two rectangles that are axis aligned. It means that they are not rotated. It simply compares x and y coordinates and width and height of these two rectangles. If they overlap, we get collision. If there is a gap between them, we know there is no collision. Let me show you two different simple algorithms you can use to detect collision between two rectangles, two hitboxes in our games. Let's say we have rectangle 1 and rectangle 2. Both of these objects have x and y coordinates and some width and height. The first way I can check if they collide is this. I create a simple if statement and I check if horizontal position x of rectangle 1 is less than horizontal position x of rectangle 2 plus width of rectangle 2. Basically, if this point is less than this point. Less means if it's to the left on horizontal x-axis. At the same time, we want to check if x of rectangle 1 plus width of rectangle 1 is more than x of rectangle 2. That means if this point is to the right from this point. We also do this vertically, so we check if vertical y coordinate of rectangle 1 is less than vertical y of rectangle 2 plus height of rectangle 2, if this point is above this point. And lastly, we check if vertical coordinate of rectangle 1 plus height of rectangle 1 is more than horizontal y position of rectangle 2, if this point is below this point. If all of these four conditions are true, we enter this code block in our if statement and collision is triggered. Else, we know there is no collision. We can also flip the logic completely. This second algorithm does the same checks, but it's a bit more efficient. If I change the logic a little bit and use OR operator, it returns true if at least one of its operands are true. Let's go through the logic here. If x of rectangle 1 is more than x of rectangle 2 plus width of rectangle 2, we know they cannot possibly collide, so this will return true, and we know straight away there is no collision. Also, if x of rectangle 1 plus width of rectangle 1 is less than x of rectangle 2, again, we know these rectangles can't possibly collide. Just one check and we know there is no collision. If y of rectangle 1 is more than y of rectangle 2 plus height of rectangle 2, there is no way for collision to happen. If y of rectangle 1 plus its height is less than y of rectangle 2, we also know they don't collide. So if at least one of these four checks is true, we know there is no collision. If all four return false, we know that the rectangles must collide. Else statement is entered and collision is detected. I hope this was visual enough and you got some clarity on how these checks work. If you have any questions, let me know. If you want to see how to implement these particular algorithms in an actual project and where exactly to place them in your codebase, I use them in many of my games, such as in Tower Defense, Frogger, Flappy Bird, and many more. I will link some in the video description. If you want to learn more with me, check out some videos on my vanilla JavaScript game development playlist. I also do web animations, generative art for beginners and more. Everything with vanilla JavaScript using no frameworks and no libraries. Hope you have fun and show me some of your creative coding projects, please. You can message me on Twitter if you want. Let's be friends. Collision detection is important if you want to build particle systems where elements interact with each other, or when you are building JavaScript games and you want to detect when two objects collide, or maybe when you want your canvas animations to interact with regular website elements. Three of the most common techniques we use for games and creative coding are collision detection between circles, rectangles, and polygons. There are also other potential scenarios, and some clever people came up with interesting ways how to detect them with code. Some are easier than others. One of the most useful ones is collision detection between two circles. You can detect if two circles collide with JavaScript very easily. The algorithm just takes two center points of our circles and checks if the distance between them is less than the radii of these two circles added together. What does that look like in code? Let me quickly show you. Let's say we have two JavaScript objects, circle 1 and circle 2. They have some coordinates, so position on horizontal x-axis and position on vertical y-axis, and some radius. I connect their center points with a line. This line represents distance between center points of these two circles. I connect position of circle 2 to my current mouse position so we can move it around. If the distance between these two center points is more than radius of circle 1 plus radius of circle 2, we know they can't collide. If the distance is the same, we know they touch, and if the distance is smaller than sum of these two radii added together, we know the circles overlap, they collide. To be able to measure distance between 2 points with JavaScript, in this case center point of circle 1 and center point of circle 2, we will use a simple and very powerful algorithm. Once you learn this and get comfortable with it, you will unlock next level in your coding and animation projects. To measure the distance between these 2 points and check if the circles collide, we need to know length of this line. We calculate it by imagining there is a right angle triangle in between, like this. In this triangle, our distance is actually hypotenuse, the longest side of a right triangle, opposite to the right angle. This is the right angle, 90 degrees. We know x and y position of center point of circle 1, and we also know x and y position of center point of circle 2. With that, we can calculate length of both arms of the right triangle. This side is simply just the difference between horizontal x position of center point of circle 2 minus horizontal x position of center point of circle 1. We can do the same thing to calculate this side. Vertical position of this center point minus vertical position of this center point. Now we have this imaginary right triangle between our 2 points. We know this side, we know this side, and we know this is a right angle, 90 degrees. Now we want to know how long is this side, hypotenuse of our triangle, opposite to the right angle. We can achieve that easily with Pythagorean theorem. It allows us to calculate relations among the 3 sides of a right triangle. Imagine we draw squares on top of each line like this. Pythagorean theorem tells us that the sum of the areas of the 2 squares around the right angle equals to the area of the square on the hypotenuse. C squared is equal to a squared plus b squared. That means c is square root of a squared plus b squared. If you want to know why this is true, check out Radu's video. I will link it in the video description. So distance between center point of circle 1 and center point of circle 2 is dx times dx, which is side a squared, plus dy times dy, side b squared. This would give us squared value, and I want square root, so I wrap it in math.squareroot like this. Now we calculated the hypotenuse of the right angle triangle, which is the distance between center points of circle 1 and circle 2. If the distance is less than radius of circle 1 plus radius of circle 2, we have collision. If the distance is exactly the same number as the sum of radius of circle 1 plus radius of circle 2, we know they touch. If the distance is more, we know there is some space between the circles and they don't collide. Visual and audio feedback that reacts to player actions and in-game events is really important if you want your JavaScript games to feel good. You can, for example, attach sound and explosion animation whenever collision happens in your game. You can also use this technique to make score points float from defeated enemies or from collected items. Today we will build an easy, fun project together that combines JavaScript audio and sprite animation. When we covered all these basics of triggered event-based animations, we will build a game that will look something like this to really put all these principles in action. I create a regular web page markup. In document head, I link my CSS style sheet. I create HTML5 canvas element with an ID of canvas1. We will draw on it with code. I also link my JavaScript file down here at the bottom just before the closing body tag. All I need to do in style CSS is to position my canvas element, so I target it with ID. I give it border 3 pixels solid black, position absolute, height 700 pixels, width 500 pixels, background black. Let's center it, so top 50%, left 50%, and transform translate -50%, -50%. This trick will only center elements that have position set to absolute, as we do here on line 3. Everything else will be drawn with plain vanilla JavaScript here in script.js file. I need to point JavaScript towards my canvas element, so custom variable called, for example, canvas is equal to document.getElementById canvas1. CTX, shortcut for context, is equal to canvas.getContext2D. This will instantiate object that holds all 2D drawing methods we will need today. Canvas width is 500. Canvas height is 700. Let's test if we set it up correctly by drawing a quick, simple shape. It's good to test your code as you go, makes it easier to debug. I set global canvas fill style to white. This will apply to fill of all shapes now, unless I redeclare it again and give it a different color. I call built-in fill rectangle method. I pass it coordinates 50-50, width 100 pixels and height 150 pixels. Perfect, we set it up correctly and we are drawing on canvas. Now let's make it more fun. I delete the rectangle and I create a variable called, for example, explosions. I set it equal to an empty array. Its job will be to hold all active explosion objects I create. I create them using JavaScript class. I call it, for example, explosion with a capital E. Constructor will expect X and Y coordinates coming from the outside. This is important because we want the animation to be triggered at a specific location, where the event happens. For example, we want it to animate at coordinates where two elements collided or at coordinates of mouse click. I will pass these X and Y coordinates to the constructor whenever I want to trigger new animation and create new object using this class. It's very simple, I will show you in a minute. So on this new explosion object, give it this.x property and assign it to X that was passed as an argument on line 8 from the outside. Do the same for this.y, vertical Y coordinate. This.sprite width will be width of a single frame in my sprite sheet. I calculate it by taking width of my sprite sheet and I divide it by the number of frames. In this case, my sprite sheet is 1000 pixels wide and has 5 frames. 1000 divided by 5 is 200. Height of my sprite is 179 pixels. Sometimes you get sprite sheets that are too large or too small, so you might want to scale it while still keeping the aspect ratio, relationship between width and height, to make sure the image is not stretched or squished. I declare this.width property and I set it equal to this.sprite width from line 11 divided by 2. This.height will be this.sprite_height divided by 2. It's important to divide or multiply them by the same number to keep the same aspect ratio. By the way, for optimization, it's always better to multiply than to divide. Division operation in JavaScript is more performance expensive, so instead of dividing them by 2, I could have multiplied them times 0.5. I will bring my sprite sheet into the project. You could declare it as a global variable, but I think it's a bit cleaner to put it as a property on class, like this. This.image equals new image. This is just image class constructor, and it will create new blank HTML image element. This.image src will give it source attribute, and I set it to boom.png. If you want to use the same file, you can download it in the video description. This image was kindly provided by one of my favorite game artists. I will link his website in the video description as well. He has a lot of cool game art there if you are interested. To animate this sprite sheet, I will crop out one frame, and I will be jumping to the right by the amount of sprite width frame by frame. To do that, I will need this.frame variable. I will set it to 0 at first. We will also need to add some behavior to this class. We do it by creating class methods. I will need one to update and one to draw my explosions. Update method will only have one job for now, to increase this.frame from line 17 by 1 for every animation loop. This.frame ++. Draw method will take values from the constructor, and it will draw current frame of animation on canvas. We will use built-in HTML canvas draw image method that takes image we pass to it and it draws it. Draw image method has 3 versions with 3 or 5 or 9 arguments, depending on how much control you want over the image you are drawing. Since we are animating a sprite sheet, we will use the longest version with 9 arguments. The arguments we need to pass to it is image we want to draw, source X, source Y, source width and source height, of area you want to crop out from the source sprite sheet, and destination X, destination Y, destination width and destination height. These last 4 arguments will determine where on destination canvas you want to place that cropped out image onto. It might sound complicated, but it makes sense if you use it a couple of times. When you learn how to use draw image method and you get really comfortable with it, you will have complete control over sprite sheets you want to animate. It's really good and so useful. So now I will replace these placeholder values with actual variables we prepared inside constructor. Image we want to draw is this.image from line 15. Source X is the only one from these 9 arguments that might be a bit more complicated for beginners. To calculate current horizontal position, I need to take sprite width from line 11 and I multiply it times this.frame from line 17. As the program runs, this.frame increases inside update method on line 20. We will get frame 0, 1, 2, 3, 4, because we are multiplying sprite width times frame. Source Y is horizontal Y coordinate we want to crop out from the source. Since this sprite sheet has only one row, source Y will always be 0. Source width is this.sprite width, and source height is this.sprite height from line 12. So now we told JavaScript what sprite sheet we want to draw and what area we want to crop out from it to display just one frame. Now I just simply tell it where on canvas I want to draw it. Destination X is this.x from line 9, destination Y is this.y from line 10, destination width and height is this.width and this.height from lines 13 and 14. Our class is complete. This is all we need to trigger this dust cloud animation and attach it to any event we want to. There are many events we can do here. Let's try one. I call window.addEventListener built-in JavaScript method. We will be listening for mouse click event, and in callback function that will run every time click event occurs. I will at first just draw a simple rectangle to make sure everything works. Fill rectangle expects 4 arguments: X, Y, width and height. I want this rectangle to be drawn at the current coordinates of my mouse click. To do that is easy. Callback function on event listener has access to built-in event objects. Usually we name it E or event like this, but you can name it anything you want. JavaScript knows that this argument passed to callback function on event listener refers to event object. You can put ABC here and it will still work as long as you refer to it as ABC later in the code as well. Basically here I am saying take event object with information about this click event and save it in a custom variable I call E. If I console log this E, I will get an error. Let's comment out line 29 for a second. Now, whenever I click on canvas, I get this console log that contains all information about current click event that just occurred. If I open it, I can see we have all kinds of details here. All we want is where on canvas this event happened, so we can draw our rectangle at these coordinates. I can see X and Y coordinates are down here as properties called X and Y. Now that I know the name of properties I'm looking for, I can use these values inside fill rectangle method. I want to draw it at X coordinate of current mouse click. I know that value is stored on my event object in a property called X, as we just saw. So I put e.x here and e.y. Width and height could be anything I want. I want my rectangle to be, for example, 50 times 50 pixels. I can't see anything when I click. That is because I used black background and default fill is also black. I set fill style to white color. When I click, you can see that we draw a white rectangle on canvas, but it's not being drawn under mouse. Why is that? In this case, event.x gives me value that doesn't account for this top and left margin between start of my web page and start of canvas. What I need to do is offset my coordinates to account for it. Good way to do that is to measure canvas position first. You can do this with one line of code. I create a custom variable called, for example, canvas position, and I set it equal to canvas from line 1, and I call get bounding line rectangle built-in method on it. Get bounding line rectangle is a very useful built-in JavaScript method. It returns an object, providing information about the size of an element and its position relative to the viewport. I can console log my canvas position variable now, and you can see the object here. It contains bottom, left, right, and top position. On the graphics here, you can see exactly what these values represent. It also contains information about its width and height and its X and Y position. You can use this to measure any HTML element on your page. If you are offsetting something, it's really useful. I delete console log on line 7. I like to clean up after myself as I go. So if I want my white rectangle to be drawn under the current mouse position, I need to offset e.x and e.y by top and left margin between viewport and canvas. Horizontal x coordinate is e.x minus canvas position dot left. Now you can see that horizontal position is exactly under mouse. I also fix vertical position by saying e.y minus canvas position top. Perfect. You can see that rectangle is being drawn towards the right bottom from my mouse cursor. This is how rectangles work on canvas. If I want my mouse to be exactly in the middle of the rectangle, both vertically and horizontally, I need to do one more small tweak here. I offset my positions by half of width and height. My width and height is 50, so I offset X and Y by minus 25. Now when I click, mouse cursor is exactly in the middle of white rectangle when I place it on canvas. I know this might be very basic for some of you, but I want beginners to be able to follow along with us. This course is for everyone. Now that we understand how to draw a simple rectangle on click, let's take it to the next level and use our custom explosion class to create sprite animation every time we click somewhere on canvas. First thing I want to do is to take this calculation that offsets and centers my horizontal and vertical positions, and I put them here in separate variables. This is just to keep my code clean and easy to read. I call them position X and position Y, and I just copy this formula in there. I can't really do minus 25 here if I want to keep my code base reusable. I need to offset it inside my explosion class. I will show you in a second. I do this position Y vertical formula. I remove console log on line 31, and I also delete my white rectangle. We will be drawing animated cartoon explosions now. On line 5, I have this array that will hold all my current active explosion objects. The goal is to use explosion class on line 8, and when we click, we push new object into this array from line 5. We cycle through all its frames using update method on line 20. We draw each step to display the animation, and then, when we reach the last frame, we remove the object from the array and we delete it. On line 31, inside click event listener, I take this empty explosions array from line 5 and I call push on it. Push is a built-in array method. It will take whatever we pass to it as an argument and it will push it at the end of the array. I pass it new explosion. The new keyword will find my class on line 8 and it will run its constructor to create a new object based on this class's blueprint. On line 9, I can see my constructor expects 2 arguments for x and y coordinates. This is important because we need to know where on canvas we want to create this triggered animation. Here on line 31, I just pass it position x and position y variables we calculated on lines 29 and 30. So now I have a way to add new explosion object into my array on mouse click. I will need a function to cycle through all objects in the array to update and draw them. Let's create animation loop. I will write a custom function called animate. Inside, I create a for loop that will cycle through all elements in the array. Sometimes if we click really fast in sequence, we will have many objects animating at the same time. Sometimes this array will be empty, it will have 0 elements and this loop will be skipped. For each object in the array, we will call its update method and also its draw method. To create animation loop, I call built-in request animation frame function and I pass it animate, the name of its parent function from line 34. Now I can call animate to kick off animation loop. Awesome, this is working, kinda. We can see old frames because we are not clearing canvas and I also need to center my animation around the cursor better. To only see the current frame, I call built-in clear rectangle method and I want to clear the entire canvas. If you look closely, you will notice we are skipping frame 0 because update method increases frame variable by 1 before we draw the first frame. I want each triggered animation to have its own timer. That way we can stagger the animation speed. On line 19, I create this.timer property and I set it to 0. On line 22, inside animation loop, I increase this.timer by 1 for each animation step. Now I can say if this.timer is divisible by 10 with a remainder of 0, this simply means run this code every 10 frames. Only when timer is divisible by 10, increase frame by 1. This will slow down the animation. Timer has to increase 10 times before frame increases once. Now we can see the initial first frame as well, and animation speed is 10 times slower than before. Let's make width and height slightly bigger on lines 14 and 15. You can see that my animation is drawn too much down from mouse cursor. Same as we did with white rectangle before, I want mouse cursor to be in the center of the animation. To do that, I can simply offset x and y by half of width and height. I can either do it here, or I can also do it here inside draw image method. It would give us the same result. I can't offset x and y here in my event listener, because at this point I don't know what width and height my animation is. I could hardcode some values here, but that would not be reusable. I think the cleanest way is to move this.x and this.y to go after width and height here, so that they can see these properties. And I offset them here. This.x is equal to x, which was passed as an argument on line 9, minus this.width from line 12 divided by 2. This centered my animation around the cursor horizontally, and this.y is y minus this.height divided by 2. Perfect. Right now I'm just adding more and more objects into my array. They stay there even after they stopped animating. You can see that if we console log explosions array from line 5. We are just adding more and more objects into the array every time we click. I need to find a way to remove the ones that have stopped animating. We could do object pooling here to avoid instantiating and deleting objects over and over, but I will show you how to do that in some more advanced tutorial. Today let's just do the simplest solution. On line 45, inside the for loop that runs through all objects in my explosions array, after I draw and update them, I check if this particular object has frame property more than 5. Frame property comes from line 18, and on line 24 we are increasing it to draw our animation frame by frame. Sprite has 5 frames, and we count from 0, so I know if frame property is more than 5, we played the entire animation. On line 44, if this particular object has frame property more than 5, I will remove it using built-in array splice method. Splice method just wants index of object we want to remove, so I for index, and I want to remove one object at this index, so I, 1. To make sure the next object in the array is correctly updated and animated after we removed its neighbor, we need to adjust index by -1. I -. Because I'm console-logging my array on line 36, in browser console I can see that we are correctly adding and removing objects from the array. Awesome. We have a solid infrastructure for triggered animation, and we can connect this code to collision coordinates, for example, and run this animation when two objects collide in our game. We can also connect it to different events and user input. It doesn't have to be a click event. To avoid code repetition, I will put this code into a separate custom function. I call, for example, create animation. I cut all this code and I paste it here. I call create animation from inside my click event. We need to pass down reference to event object to calculate coordinates, like this. Look what happens if I connect it to mouse move event. It gives us pretty cool effect. Experiments. This looks like some deep sea creature. When I move it like this, you can see that the first frame of dust cloud animation is always rotated the same way. Maybe I want to rotate it at different angle every time we create a new explosion. To do that, I use built-in save and restore HTML canvas methods. Let me just write this and then I will explain what's happening. Translate will set rotation center point in this case. I want to rotate around its center, so this.x and this.y. I want each one to be rotated by a different random angle value. I create a new property on line 20 called this.angle. Circle is 360 degrees. HTML canvas rotate method expects radians, so 360 degrees is roughly 6.2 radians. This.angle will be a random number between 0 and 6.2. I pass this.angle to canvas rotate method on line 31 like this. Now it's rotating too much. It's because I translated draw in context to this.x and this.y on line 30. Then I rotate it and then I go from that point further to another this.x and this.y here. X and Y coordinates for our animation are already captured here on line 30. So on line 32 I replace this.x and this.y to 0. Think about it this way. I use translate, which would be 0.00 on canvas, to this.x and this.y. So between these save and restore calls, 0,0 is actually this.x and this.y. That's better. I also need to offset it by this.width divided by 2 and this.height divided by 2 here inside draw method, and remove it on lines 14 and 15. This is how you rotate anything on canvas. You save the current state of canvas to make sure the following changes affect only one draw call. I translate rotation center point on top of my current object I want to rotate. I rotate the entire canvas context by a random angle value. We draw our image and we restore canvas context to the original save point to make sure this translate and rotate only affects one draw call of one object. Canvas rotation is one of the more difficult concepts for beginners to understand. I spent the entire Halloween episode explaining it, so don't worry if this was too fast for you. If you want more details on how to rotate things on canvas, I will link that episode in the video description. For now, let's just move on. You can see each dust cloud is now rotated randomly, so the trail itself looks more chaotic, as every dust trail should. Let's comment out mouse move event. Now we have this nice cartoon dust cloud animation whenever we click on canvas. It's missing something. Let's give it some sound. It's really easy to attach sounds to event animations in JavaScript. I go to opengameart.org and let's click Browse and Sound Effects. I remember there was one I really liked. Here on left I will type magic in title search. Oh yes, it's this one, Magic Special Effects Pack. It contains 4 cool magic sounds. I download it and I take the one called Ice Blast. I rename it to boom.wav. For you the path might be different if you chose different file or you placed it in a different folder. I only want to play the sound file once per animation, so in update method on line 25, I say if this.frame is equal to 0, take this.sound from line 21 and call built-in play method on it, like this. Choosing the right sound and animation speed is very important to how your game feels in the end. If you do it well, your game will be satisfying and your users will love to play it. Don't forget to click the like if you learned something new today. For more vanilla JavaScript game development and animations, check out my playlist. I will link relevant videos in the description down below. Thanks for coding with me today. Hope you had fun. Do you want to build awesome games and master front-end web development at the same time? In this vanilla JavaScript and HTML5 canvas game tutorial, I want to show you 5 techniques I wish I used sooner. Today we will build a game completely from scratch, step by step, with no frameworks and no libraries. We will learn how to achieve pixel-perfect collision detection using colors, how to use timestamps and delta time to make sure our game runs at the same speed on different machines. We will learn about arrays, and I will show you how to remove all the game objects using array filter method, and how to use array sort method to create a correct draw order in a 2D game. We will also talk about modern JavaScript syntax, and we will learn how to make our animation code cleaner and less repetitive with spread operator. I will also share many small tips and tricks as we go along. Students of today's course will get 2 premium sprite sheets completely for free, kindly provided by this amazing artist. Check out his website for more. Click the like please if you are excited and ready to learn. Let's talk about JavaScript. Have fun! I want you to build projects you can show off to someone and be proud about. So as usual, we will build a game, and by the end of this tutorial, you will have a complete project. I learned some of these techniques from my friend Radu. He has a lot of other cool things to teach you. If you want, you can go and check out his courses. I will link some in the video description. Some of you tell me that you only make games by animating divs and other HTML elements. It's a great way to start and learn the basics. HTML canvas can handle many more moving objects at the same time. So if you want to try and build games that have a little bit more complexity, maybe this is the time for you to give Canvas a chance. Let me show you it is easier than you think to build interactive animated projects with it. I will take you through it step by step and help you understand. I have an introductory game development series and a beginner playlist where I go slower over all the important techniques. If you find yourself struggling at some point or you think I'm going a bit too fast, maybe try to watch that one first. Over there, we also create really cool projects, but I keep beginners in mind at all times. It might be an easier starting point for you, and then you will be ready to take on videos like this one and actually properly understand everything. I will leave some links in the video description. Let's go! Let's create some ravens. I will have an array that will hold all my raven objects. It needs to be a let variable, not const. I will explain why in a minute. I create a custom class called Raven. It will be a blueprint based on which all my animated ravens will be created by JavaScript. Constructor will create one blank new object every time it is called, and it will assign it properties and values as we define them here. It will have width property, and its value will be, for example, 100 pixels. Height will be 50 pixels. This.x starting horizontal x coordinate will be just behind the right edge of canvas, so they can fly across to the left, so canvas width. Vertical y coordinate will be a random number between 0 and canvas height. Since rectangles on canvas are drawn from the top left corner, going right and down, I don't want any ravens to be partially hidden below the bottom edge of screen. Initial y position will be a random number between 0 and canvas height minus the height of a raven. Between here and somewhere around here. It needs to be in brackets like this to give us the correct range of values. Direction x will be horizontal speed basically. It will be a random number between 3 and 8. I want ravens to bounce up and down as they fly. So the initial vertical speed, I call direction y for example, will be a random number between minus 2.5 and plus 2.5. Minus values will move upwards, plus values will move the raven down along the vertical y-axis. Update method will move the raven around and adjust any values that need to be adjusted before we draw the next frame. At first I will just simply move it to the left, so this.x from line 11 minus equals this direction x from line 13. Draw method will take these updated values, and any drawing code we put here will represent single raven object visually. First, let's start with a simple rectangle. I call built-in fill rectangle method and I pass it x, y, width and height. Raven class is complete. We have a way to create ravens. Let's create animation loop. I create a custom function I call, for example, animate. It will take argument I call timestamp. This will be a numeric value in milliseconds, so 1 second will be number 1000. I will show you exactly how it works. Any code inside this animate function will run over and over, updating and drawing our game frame by frame. The first thing we will do between every frame is clear old paint. Old drawings from the previous frame. So clear rectangle, and I want to clear the entire canvas from coordinates 0, 0 to coordinates canvas width, canvas height. We will run some code in between, and then at the end we will use request animation frame method that will call animate again, create an endless animation loop. I will console log test to make sure it works, and I also need to call animate like this on the first page load to trigger the first loop. In browser console I can see the loop is running, perfect. It's good to test your code as you go to make sure there are no typos. It's safer than to write the entire project and then try to look for bugs there. Step-by-step approach will save you a lot of time. I can also test if my Raven class is working. I will use it to create many ravens, but I can also just create one. I create a variable called Raven and I assign it to new Raven like this. This will create one Raven object for me, which will have access to update class method from line 16 and draw method from line 19. I call it from inside my animation loop, and here's my Raven. It just flies over once. If I refresh the page, it flies again. This works. So far we are doing great. Instead of having one Raven, I want to create a new Raven periodically, and I want to make sure that periodic event is triggered at the same interval on very slow old computers and on brand new gaming super PCs. To make sure the timings in my game are consistent and based on time in milliseconds rather than on the power of my computer and its ability to serve frames at a certain speed, I will use timestamps. I will compare how many milliseconds elapsed since the last loop, and only when we reach certain amount of time between frames, only then we will draw the next frame. It's actually very simple, but it might take some time to get used to it if you are a beginner. Let's do it and see how it works. What is happening here, we are calling animate using request animation frame. Animate becomes a callback function on request animation frame method, and default JavaScript behavior for callback here is to pass it automatic timestamp as an argument. Its value is in milliseconds. Just so you know where this timestamp will be coming from, it's a default JavaScript behavior when using request animation frame. It will pass its callback function, in our case animate, automatic timestamp argument. We will see it better in a minute. As the loop runs, request animation frame calls animate over and over, passing it timestamps. My goal here is to take time from the current loop, save that value, run the loop again with a new timestamp value, and compare them to see how many milliseconds it took in between frames. I will need some helper variables here. Time to next Raven will be a variable that will accumulate millisecond values between frames until it reaches my interval value and trigger next frame. Initially, it will start at 0. Raven interval will be a value in milliseconds. Every time to next Raven accumulates enough to reach 500 milliseconds, it will trigger next Raven and it will reset back to 0 to start counting again. I will also need a variable that will hold value of timestamp from the previous loop. The initial value will be 0. Inside my animation loop, I will calculate delta time. This will be a value in milliseconds between timestamp from this loop and saved timestamp value from the previous loop. After I used last time value to calculate delta time, I will assign last time variable from line 8 to the new timestamp passed here in this loop, so that we have that value ready to compare in the next loop. Let's console log timestamp. I can see I misspelled last time here. Capitalization of letters is very important in JavaScript. You can see in console I'm getting timestamps in milliseconds since the loop started. The very first value is a second, so it goes like this: 7, 8 seconds and so on. So this is the automatically passed timestamp value here. It's generated by default by JavaScript because we made animate into a callback function on request animation frame method here on line 33. There is a way to do this without calculating delta time at all, but I haven't tested that, and I'm not sure what is the browser support for that technique, so let's go with this tested safer solution today. I will remove console log. Leaving too many console logs in your projects, especially the ones running so often like this, can affect your performance, so keep that in mind. On line 6, I have time to next Raven variable. Here in my animation loop, I will increase its value by delta time for every animation frame. I will console log delta time now. Again, I need to be careful about spelling my variables correctly here. I can see that on my computer, time between frames is around 16 milliseconds. My computer is powerful and it is able to serve a new frame every 16 milliseconds. On your computer, the number might be different. I would actually be very interested to know if it's the same number or a different one for most of you. If you are following and coding with me, can you leave a quick comment with that number, please? You can just type 16 if it's the same number, or whatever different number you are getting right now. So time to next Raven starts at 0 and is increasing by this value of around 16 milliseconds per each frame. On line 7, I created a variable called Raven interval and I set it to 500 milliseconds. In my animation loop, I will say when time to next Raven reaches this Raven interval, when this number that starts at 0 and increases by the amount of milliseconds that happened between frames reaches 500, at that point we will take Raven's array from line 10 and use built-in array push method. I will pass it new Raven, which will trigger my Raven class constructor. Create one new Raven object and it will push it inside Raven's array. When that happens, I set time to next Raven back to 0 so it can start counting again from the beginning. I know I just said Raven a lot. Time to next Raven starts at 0, it increases by the amount of delta time, by the amount of milliseconds between each frame, which will be dependent on performance of your computer. However, since slower computers will take longer to serve the next frame, their delta time will be a higher number, and it will move towards our target Raven interval in bigger steps. As a result, this code will be triggered at the exactly same time on slow and fast computers. This is one way how you can properly trigger periodic events in your projects using timestamps. This might be a bit too much to wrap your head around if you are a beginner. It's one of the reasons I don't always use timestamps in my animation tutorials, because I can't really explain all of this in every single video, but try to learn it if you can. If you still don't get it, don't worry. I will explain it in future projects again, so eventually it will start making more sense. Repetition and practice is the best way to learn, at least for me it is. I console log Ravens and I see nothing is happening, even though my animation loop is running. It seems that this if statement never evaluates the true, so the code inside is never triggered. Console log is great for debugging. I console log time to next Raven first. Oh, I can see its value is a none, not a number. Here's our problem. Why is it this value? It must be because we are adding delta time to it here. I console log delta time and I can see that the first initial value is also not a number. Delta time is calculated here on line 30, so now I console log timestamp. And this is the root of our problem, that cascaded all the way through my variables that use each other to calculate their values. When the animate loop starts, the very first timestamp is undefined because timestamp only gets created on the second loop here on line 39 when we call request animation frame. To fix that is easy. I just need to give timestamp a starting value on the first call of animate that starts my animation loop here. I will pass it timestamp of 0 as an argument. Awesome, that fixed it. And since I'm console logging Raven's array on line 36, I can see it adds new Raven object to the array every 500 milliseconds. I remove the console log. We have data for Ravens inside the array. We just need to cycle through that array through every single Raven object and call their update and draw methods so that we can actually see movement on canvas. I declared my Ravens array here on line 10. Inside animation loop, I will use this syntax, which might be a bit unusual for you. Here I'm creating so-called array literal by just dropping square brackets like that. I'm creating a quick new array on the fly, and these 3 dots are so-called spread operator. Now I'm spreading my ravens array inside this new quick array I just created. Spread operator allows us to spread iterable, such as this ravens array, to be expanded into another array. Let's finish writing this line of code and I will explain why I'm doing that. Since we are dealing with an array, I can call built-in array for each method. I need to assign it a variable name for each object in this array, so we can use it as we iterate, as we cycle through it. I will call that variable, for example, object. So this object variable now represents each individual Raven object in Raven's array, and I can say for each Raven object in Raven